Hello, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to the BIOS. Today I'm going to give you some BIOS basics. We're going to access a BIOS, and then we'll talk about how to update a BIOS. And with that, let's go ahead and begin this session. So of course, we begin with BIOS basics. So what are the basics of BIOS? Let's begin with what the BIOS is. BIOS stands for Basic Input-Output System. It is the first software to run on a PC when the power is turned on. It is actually a firmware software that establishes the base behavior of the PC. It sets the hardware configuration of the system. It tells the PC what hardware to initialize and what the priority of that hardware is. It also points the PC to the files that are needed to boot the operating system. Now, BIOS is stored in non-volatile random access memory, NVRAM. That's a special type of memory that doesn't require an electrical charge to keep what's in the memory. It is designed and coded for the specific motherboard that it resides on. BIOS updates can add functionality to a system that wasn't originally present when the motherboard was installed. Now let's move on to how to access the BIOS. So why might you need to access the BIOS? Well, system stability may have been compromised by the addition of new components. Some people, gamers, adjust settings in the BIOS to improve performance. More importantly, the BIOS may need to be entered in order to help in the system recovery process. You know that brother-in-law of yours that is always got his PC infected? He called you up to seek your help. His computer won't even boot now. Well, you can resolve that issue if you can get into BIOS. So let's access a BIOS now. Now, for the purposes of this demonstration on how to access the BIOS, I'm going to be using a virtual machine, a VM, that's on my laptop. Now, the BIOS for this virtual machine is pretty basic, but it will work for the purposes of this demonstration. So let's go ahead and fire up this virtual machine. The first thing that you need to know about accessing a BIOS is how to do it. And in this case, I need to hit the delete key during the post, the power on self-test. Different BIOSes may have a different method of accessing. Some of them require that you hit the delete key, some the F2 key, and there are other combinations out there. It's up to the manufacturer of the BIOS to set it. So here we are on the main page of the BIOS setup utility. Let me get this centered a little bit better. So here we are on the main page of the BIOS setup utility for this virtual machine. The first thing that you should notice is that the manufacturer of this BIOS is AMI. They're one of the main manufacturers of it. And this BIOS is version 8.00.02, and it was built on August 14th, 2009. It is not the most current version of BIOS. Now, in most cases, when you access your BIOS, you're not going to have access to your mouse because it hasn't been initialized yet. So you have to use your arrow keys in order to navigate. Now let's take care of your brother-in-law's problem. Remember, he can't boot. He's gotten his system so infected it will no longer boot. So we would arrow over to the boot tab and take a look at the boot priority. The boot priority in this virtual machine is to look for the hard drive first and then to look for a CD-ROM. With this information, I could create a system recovery utility CD-ROM that was bootable and reset the priority so that it would boot to the CD-ROM first, so I could clean up my brother-in-law's system and then get him going again. There is a ton of information that is available to you in the BIOS. Now, this is a pretty basic BIOS, so I can't show it all to you. As a matter of fact, I can't show most of this to you. But quite often you have system configuration information. Not only the boot sequence, but also device status and things like system speed, that's your clock speed, whether or not you have virtualization support, And you also have BIOS security. Now this one does have BIOS security. I could put in a password here that would prevent my brother-in-law from changing my BIOS settings on his system to keep him out of it and to make it easier for me to fix it the next time. A lot of BIOSes also have monitoring capability. They can tell you what the temperature is inside your case and what the temperature of your CPU is. You can also see fan speeds on a lot of BIOSes and adjust those speeds. A lot of BIOSes also have built-in diagnostic information and the ability to use that information to tweak your system. But now that we've used your system's recovery utility disk and fixed your brother-in-law's computer, let's exit out of here. If you notice, we have to save the configuration, by the way. And if everything worked right, then we're back up and running. And voila, your brother-in-law's system's running it once again. Now let's move on to how to update the BIOS. Before I begin talking about the how to update a BIOS, I need to issue a warning. The BIOS is required in order for the system to boot. Making a mistake while updating the BIOS may have serious consequences for your system. You may not be able to boot. So let's talk briefly about why the BIOS may need to be updated. Well, you can extend the productive life of a system by adding additional functionality to the system by updating the BIOS. You also might need to update the BIOS to resolve issues that were unknown at the time that the BIOS was created. So what is the specific process required to update the BIOS? Well, the motherboard or system manufacturer is responsible for developing the BIOS update process for each motherboard. So in order to update the BIOS, you need to follow the manufacturer's instructions to the letter to avoid a catastrophic failure. Now that concludes this session on the introduction to the BIOS. I talked about BIOS basics. I talked about how to access BIOS, and I showed you accessing a BIOS. And then I briefly touched on how to update the BIOS. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure another one will. Hello, I'm Brian Farrell, and welcome to PACE IT session on the introduction to the motherboard. Today we're going to be introducing the motherboard. We will also talk about different form factors and then some common factors of the motherboard. And with that, let's go ahead and begin this session. So let me begin by introducing the motherboard. The motherboard is the physical foundation layer for every system. The motherboard is also known by other names. It can be called the system board, the base board, the MB, or the MOBO. The motherboard, along with the BIOS, establishes what the system is and what components may be present. Some motherboards are very simple and some are very complex, but they all do basically the same thing. They lay the foundation for your system. And with that introduction, let's move on to different form factors of the motherboard. Now, the form factor of a motherboard is basically its size, and there are just a couple of main categories. There is the ATX. That is the basic form factor for a full-size, full-power PC. And the ATX size is 305 millimeters by 244. There's also the micro ATX. It's more compact in size, and it usually has a little less capabilities than the ATX. Now, sizes within the micro ATX may vary within a range. At its largest, an ATX motherboard can be 244 millimeters by 244, but it can also go down to 171.45 millimeters by 171.45. The next main form factor category is the ITX, which can also be called the mini ITX. Now this is a low power consuming form factor. It's even more compact than the micro ATX. The ITX form factor often doesn't require the use of a fan for system cooling. The standard size for an ITX motherboard is 170 millimeters by 170 millimeters. Now, a couple of special mentions on the ITX form factor are the Nano ITX and the Pico ITX. The Nano ITX is 120 millimeters by 120 millimeters, and the Pico is 10 millimeters by 7.2 millimeters. That's tiny. These tend to be used for specialty applications, and they're very low power consuming motherboards, but they also have very limited capabilities. Now let's move on to some factors that are common to almost all motherboards. And you notice that I put a caveat in that, and we get to begin with a disclaimer. As a general rule, these factors are present on all ATX and ITX motherboards, but it is up to the manufacturer to decide what is present and what is not. So what are these common factors? Well, they all have a spot for a CPU, for a central processing unit. All of them have spots for RAM. Some is removable, some are not. Almost all have chipsets, the North Bridge, South Bridge, and BIOS, although newer Intels don't require the North Bridge. They all have power slots. That's for the main power and in some cases for CPU auxiliary power. Some of the optional connections that are commonly found on motherboards are fan connectors, expansion slots, back panel connections, and front panel connections. Now, I said these are optional because they're not present on every single motherboard and are highly dependent upon the manufacturer. Now, that concludes this session on the motherboard. I introduced the motherboard. I talked about different form factors of the motherboard, and then I talked about some common factors of motherboards. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on random access memory. Today we're going to be introducing RAM, we're going to talk about different types of dynamic RAM, and then we will cover some special considerations of random access memory. And with that, let's go ahead and begin today's session. And of course, I'm going to begin by introducing RAM. When most people talk about computer memory, they're talking about dynamic random access memory, DRAM, not the St. Louis RAM. DRAM is not the only type of memory that is present, but it is the one that most people are familiar with. DRAM is used to hold data and pass it between the CPU and storage devices. We use dynamic random access memory because it's quicker and more responsive than using the storage device itself, and it can hold a lot more data than the CPU. We commonly refer to dynamic random access memory as RAM, random access memory. So how does RAM work? Well, it uses transistors and capacitors to hold electrical charges. Arrays of these transistors, called registers, the registers are either on or off. That's the binary 1 or 0. If there is no electricity, there is no memory. Now, there are two basic types of RAM. And the first type is static RAM, SRAM. Static RAM is located on the CPU die or just off of it. It's commonly referred to as cache or cache memory. It's super fast, but it's also very expensive, so it's used in limited amounts. Dynamic RAM, on the other hand, is always located off the die. It's fast, but not as fast as static RAM. But it's also relatively inexpensive, so we can use a whole lot more of it. Now let's talk about types of dynamic RAM. And we begin with the dual inline memory module, the DIMM. Now the DIMM is both obsolete and cutting edge. Before the introduction of the DIMM, memory modules could only receive current through one side of their electrical contacts. This limited the memory bus to only being 32 bits wide. The DIMM could receive electrical current through both sides of the electrical contact, and the memory bus grew to 64 bits wide. All current RAM are types of DIMM. So now let's move on to synchronous dynamic RAM, SDRAM. This is the true beginnings of modern RAM. It was the industry standard beginning in 1993. It was synchronized with the system clock and could perform an operation with every cycle of the clock. It's currently considered obsolete. Why? Well, because it was replaced by DDR. Now, DDR was introduced in 1996, and it effectively doubled the possible rate of data transfer by taking advantage of the falling and rising edge of the clock cycle. That means that it could perform 2 operations per cycle. The speed of the RAM is determined by a specific formula. It's the clock rate times 2 times 64 divided by 8, and that gets you your megabyte transfer rate. Now, if Intel had had their way, DDR RAM would have been replaced by Rambus, Dynamic Random Access Memory. Now, Rambus was a proprietary standard developed by Rambus Inc. that was initially supported heavily by Intel. It had to be installed in pairs, or you had to use a special device called a continuity module, also called a RIM, in order for it to function. It was faster than DDR, but it was not as cost-effective as DDR, so it never really caught on. Now let's talk about DDR2 and DDR3. DDR2 doubled DDR's performance. The formula to figure out its transfer rate is clock rate times 4 times 64 divided by 8. That was superseded by DDR3, which doubled DDR2's performance and is the current standard. Its formula is clock rate times 8 times 64 divided by 8. Super fast. Soon we're going to see DDR4 and DDR5 being common, but not quite yet. Then there's small outline dual inline memory modules, SODIMM. This is compact memory modules that are used in small form factor computers, like laptops in most cases, and in tablets. Now, SODIMM can be DDR, DDR2, or DDR3, all depending upon the manufacturer. There's also parity and non-parity RAM. Parity RAM modules have an extra bit, a parity bit, that is used to check for errors in RAM. It can't fix the errors, but they can find it. It's more expensive than non-parity RAM, and it's not really needed anymore because applications check for errors now. Then there's error correcting code RAM, ECC RAM. ECC RAM can detect and recover from errors in memory. It's much more expensive than standard RAM, but it should be used in situations where an error can't be tolerated. Now there's another thing to consider about RAM. It can be dual-sided or it can be single-sided. Dual-sided RAM is when the memory modules on a stick are separated into ranks. Only one rank may be accessed at a time. Single-sided RAM, on the other side, is when memory modules are not separated into ranks. It is faster, but more expensive than dual-sided RAM. Now let's move on to some special considerations of RAM. This first consideration is single-channel versus multi-channel RAM. In single-channel RAM, all banks or slots of the RAM make up a single 64-bit bus to the CPU. In multi-channel RAM, the banks of RAM may be grouped together to form a wider bus to the CPU, and that bus may be 128 bits or 192 bits wide. To take advantage of the multi-channel abilities of the RAM must be installed in matched sets. And you need to follow the motherboard documentation when installing multi-channel RAM. You also need to know what type of RAM your motherboard supports. A motherboard will only support one type of RAM. You can't mix different types together. The RAM modules are keyed on the bottom so that they can't be placed into the wrong type of RAM slot. And the final thing that you need to consider, you can install different speeds of RAM together. but you need to remember that the RAM will only function at the speed of the slowest module. Now that concludes this session on random access memory. We talked about RAM, we talked about different types of RAM, and then some special considerations about RAM. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on expansion cards. Today we're going to be talking about the why of expansion cards, different types of expansion cards, and then we'll cover the basic steps of expansion card installation. Now with that, let's go ahead and begin this session. So we're going to begin with the why of expansion cards. Well, thanks to the highly modular nature of the PC, expansion cards are a great way to increase the functionality or capabilities of a system. Expansion cards can extend that capability of the system by adding more resources. Expansion cards can increase the functionality by adding abilities that weren't in the original operating system. Expansion cards are often a fairly inexpensive solution to a multitude of issues that may occur. That is the why of expansion cards. Now let's briefly touch on different types of expansion cards. We're going to begin with sound cards. They expand the sound capabilities of your PC. They're popular with gamers and those who watch videos and/or television on their PCs. You can go from mono sound to stereo sound to surround sound with a sound card. Let's move on to video cards. Video cards can increase the overall performance of your system depending upon the card that you install. They can also add the ability to add multiple monitors. One of the ways that they increase performance is by taking the workload off of the CPU and transferring it to the video card. A good video card is a wise investment. Then there's network cards. Most motherboards have built-in network cards nowadays, but they can fail, or they might not connect to the right type of network in your situation. Or you might need to connect to another or different type of network, or make multiple network connections. That would be the reason to add an expansion card. Another reason to add expansion cards would be legacy applications. Most systems nowadays do not come with a serial or parallel port, but some applications and situations still call for those type of connections. You can add an expansion card that has a serial and/or parallel port to your system. There are USB cards. You can add more USB ports to your system. You can also add newer versions of USB by using an expansion card. It's the same kind of situation with a FireWire card. You can add more FireWire to your system or just add FireWire to your system. And by installing an expansion card, you can update your system. There are expansion cards that help with storage. There are different storage solutions through expansion cards. So you need to add a SCSI tape array? Well, you can add a card that allows you to connect to a SCSI. There are also expansion cards that are solid-state drives in their own right. They're really fast. They also tend to be fairly expensive, though. They are a unique solution to storage. Let's talk about modems. Most systems don't come with built-in modems anymore either. It's kind of like the serial and parallel ports. But if you still need to connect to a legacy virtual private network, you're going to need that modem. That's where an expansion card that has a modem built into it will resolve that problem. There are wireless and cellular network cards. They allow you to take advantage of wireless networks. And a cellular card can take advantage of LTE or 4G networks, although caution, additional data charges may apply. A TV tuner card allows a PC to make a cable television connection. This is a popular option for the home theater PC. Cable television can be routed through or watched on the PC. Video capture cards are used to capture video images. Specialized cards are used to capture video and or still images that cross through the PC, and they may be combined with a TV tuner card. And finally, we're going to end with the riser card. This is an adapter for other cards. It plugs in and offers the ability to install another card at a 90-degree angle. You use a riser card when space is tight within the case. Now let's cover the basic steps of expansion card installation. Before we get started on the physical steps, there is some planning that's involved. The first thing that you need to determine is what you're trying to accomplish. There are often multiple ways to solve an issue. Which one is right for this situation? The next thing that you need to consider is there an open slot? It really doesn't do you much good if there's not. If there is not an open slot, then you need to make a decision. You need to decide on how to free up a slot or whether or not you need to go a different route. Next, is there enough physical space inside the case? Check the dimensions of the proposed card to make sure that it will fit inside the case. And finally, is there a better option? Do your research and plan for the future. It can often be less expensive to plan for the long run than to go a little less expensive but be hindered in your future use. Now let's move on to the physical steps. Step 1. You need to read the documentation that comes with the card. Specifically look for when the driver needs to be installed. Does it need to be installed before you insert the card or after you insert the card? Step 2. Power down and open the case. Make sure you follow all safety procedures. Step 3. Determine which slot you're going to use. If there's an open slot, install the card, making sure it is firmly seated. If you're going to install it into an occupied slot, remove the old card and then install the new one, making sure it's firmly seated. Then you close up the case and power up. Once the system is powered up, test for functionality. Make sure it works right. And finally, check the manufacturer's website. Often there's an updated driver or a firmware update that you want to install to make sure that you have all the functionality that is required. Now that concludes this session on expansion cards. We covered the why of expansion cards, we covered the types of expansion cards, and then I briefly touched on the basic steps of expansion card installation. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on storage devices, part 1. We're going to be talking about types of storage devices, and then I'm going to dive into SCSI storage devices, and then we'll talk about RAID. Now I have a whole ton of information to cover, so let's go ahead and get right in. So we'll truly begin this session with a discussion on types of storage devices. First up is the traditional internal hard disk drive. It's the spinning platter type of hard disk. It had two types of interfaces. It had the Parallel AT attachment interface, the PATA interface, and the SATA interface, Serial AT attachment interface. These are still very common in today's computers. Then we move on to the more non-traditional types of internal hard disk drive. There's the solid state drive, the SSD. There is the small computer system interface drive, the SCSI drive. And then there are RAID systems. Now I need to cover this, but you probably won't find these in a modern system, and that is the floppy disk drive. Floppy disk drives were first commercially successful with the 8-inch floppy. Now it is extremely obsolete now. It was replaced by the 5 1/4-inch floppy disk drive. But it too is also obsolete. It was replaced by the 3 1/2-inch floppy, the most successful of all the floppy disk drives. Now they're not very common now, but you may still come across one in the workplace, so you need to know about them. They had a maximum capacity of 1.44 megabytes. So now let's move on to the CD-ROM, the compact disc read-only memory. When these first came out, they commonly used the PATA interface, but now more than likely you'll find them with the SATA interface. The CD-ROM has a maximum capacity of 700 megabytes. Originally, CDs could only be read from and not written to. But as technology advanced, guess what? Things changed. Now, a CD-RW is a combo drive, also commonly known as a CD burner. It allows for writing data to the CD. And of course, technology marches on, and we came up with the DVD-ROM, the digital video disc read-only memory. Now, it has a maximum capacity of 4.7 gigabytes in its single-layer format and 8.5 gigabytes for a dual-layer format DVD. Now, DVDs also came out in the DVD-RW. Just like the CD-RW, it's a combo drive that allows for writing to the DVD. Then we have the BDR, the Blu-ray disc read. Its common internal interface is the SATA interface, and it has a maximum capacity that ranges from 25 gigabytes to 128 gigabytes for a 3-layer BDR. Now, a BDRE is a combo drive that can write and erase data to the Blu-ray disc. Now let's talk about some external storage devices. As a general rule, all of the internal storage devices are available for an external connection. The only difference is that the interface tends to be different. Now, common external connections can be made through USB, Universal Serial Bus, or FireWire, the IEEE 1394 standard. And now we have what's called eSATA, External Serial AT Attachment, that some devices may also implement. Other types of external storage devices would be the Network Attached Storage, the NAS. There's also the Storage Attached Network, the SAN. More than likely, you will not find these in your average small office, home office, but you can find them in the enterprise environment. Then there are also cloud storage solutions, which tend to be a type of storage attached network. And as a rule, these all involve transferring your data over Ethernet. Now let's move on to SCSI. So we get to talk about the Small Computer System Interface, SCSI, and it was standardized in 1986. Now, SCSI was not very popular in the home market because SCSI devices cost more than regular devices, and they are a little bit more difficult to manage than your standard storage device. But SCSI was very popular in the enterprise market because the devices were very robust and could be fairly easily, chained together. When devices are chained together, the last device in the chain needs to be terminated in order to stop signal bounce. In order for the chain to work, the last device needed to be properly terminated. Now, SCSI's longevity has led to different versions being on the market at the same time. Another thing that you need to know about SCSI devices is that many of them were hot swappable, meaning that the system didn't need to be shut down in order for a defective device to be replaced and/or for a new device to be added into the chain. Now, there are two main iterations of SCSI. There's narrow SCSI. That means 8 total components could be chained together, 1 controller and 7 devices. And then there's wide SCSI. That's where 16 total components could be chained together. Again, 1 controller and then 15 devices. Now let's move on to RAID. RAID stands for Redundant Array of Inexpensive Disks. Now, RAID is taking multiple disks or storage volumes and combining them to achieve performance gains, or fault tolerance, or performance gains and fault tolerance. The first RAID that we're going to talk about is the RAID 0, also known as a stripe set. Now, this requires a minimum of 2 volumes. Data is striped between the drives. Write a block of data to one volume, then write the next block of data to the other volume. Now, RAID 0 offers the best performance out of all of the RAID types in most situations, but it is not fault tolerant. And what that means is that if one drive fails, the whole stripe set is ruined. To combat that, RAID 1 was developed. Now, RAID 1 is also known as a mirror set. Now, it too requires a minimum of 2 volumes, but the data is mirrored between the 2 drives. The system writes each block of data at least twice. Now, RAID 1 offers extremely fast read times, but it's relatively slow in the write time as it needs to write twice. But it is fault tolerant. If one drives fail, the data is still safe. In an effort to improve RAID performance, RAID 5 was developed, and it can also be called striping with parity. Now, RAID 5 requires a minimum of at least 3 drives. In a RAID 5 setup with 3 volumes, it stripes data across 2 drives and adds a parity block to the 3rd drive in a rotating manner. The parity block adds fault tolerance to the RAID. If any one disk fails, the data can still be rebuilt by combining the data on the other 2 disks and combining it with the remaining parity blocks. Now, RAID 5 is not as fast as RAID 0, but offers better performance than RAID 1 while still providing fault tolerance. Now, if you have the ability, you might want to implement RAID 10, which is also called a stripe of mirrors, or it is sometimes referred to as RAID 1 plus 0. Now, it requires a minimum of at least 4 volumes, and it involves a mirror set that is also striped. Next to RAID 0, it offers the best performance, but it also offers a high degree of fault tolerance. Now, that concludes this session on storage devices. We talked about types of storage devices. I briefly covered SCSI, and then we went into RAID a little bit. Now, on behalf of PACE IT, thank you for watching this session, and I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Storage Devices Part 2. Today we're going to discuss the anatomy of a hard disk drive, then we're going to talk about some aspects of the traditional hard disk drive, and then we're going to cover some items about solid-state drives. There's a fair amount of information to cover, so let's go ahead and begin this session. And of course, we begin by talking about the anatomy of a hard disk drive. So hard disk drives are composed of various components, including multiple metal disks that are called platters. These are held in place by a spindle which rotates the platters. Then there's the armature, which moves the read head across the platters to read and write data to the drive. Getting a little deeper into the anatomy of a hard disk drive, well, the platters are logically broken up into tracks, think traffic lanes, in which the data is electromagnetically laid down. The tracks are logically broken up into sectors, think addresses, in order for the PC to know where the data is located. Now, the faster the platters spin, the faster the drive can read and write data. Common spin rates range from 5,400 RPM all the way up to 15,000 RPM. But in the consumer market, you're more likely to see the 5,400, the 7,200, or the 10,000 RPM hard drive. In the enterprise market, you're much more likely to come across the 10,000 RPM or the 15,000 RPM hard drive. So now let's move on to some other aspects of the traditional hard disk drive. And we're going to begin with its traditional interface to the motherboard, and that would be the Parallel AT Attachment, PATA. Now, this could use either the Integrated Drive Electronics, IDE, or Extended Integrated Drive Electronics, EIDE, interface on the motherboard. The actual interface connection on the motherboard was a 40-pin connector. Now, if the motherboard only supported IDE, a 40-wire, 40-pin ribbon cable was used to connect the hard drive to the motherboard. If the motherboard supported EIDE, an 80-wire, 40-pin ribbon cable was used, and higher transfer speeds were achieved. The maximum speed, or rate of transfer, of a PATA drive was 133 megabytes per second. Now, power was supplied to the hard drive through a 4-pin Molex plug. Now, with the PATA interface, a master-slave relationship was used to determine which hard drive was bootable when multiple devices were present on the same ribbon cable. The master-slave status could be set by jumpers on the back of the hard drive. With the introduction of EIDE, there was another relationship that could be chosen, and that would be cable select. And what that meant was where the device plugged into on the cable would determine if it was the master or the slave drive. Then along came serial AT attachment SATA. It can be used with traditional hard drives or with solid-state drives. Now, it's a newer interface standard and it achieves much higher transfer rate. SATA 1.0 was capable of 1.5 gigabits per second transfers. SATA 2 was capable of 300 megabytes or 3 gigabits per second transfer, and SATA 3 has a theoretical transfer rate of 6 gigabits per second. Now on SATA, only one drive was allowed per cable, and your boot priority is no longer established at the drive, but it is set in the BIOS settings of the motherboard. Now the SATA interface uses an L-shaped connector with a 7-wire 7-pin cable. On an interesting note, all SATA drives are hot swappable, meaning that the PC and the device do not need to be powered down in order to replace it and put a new one in. But that's of limited value when the SATA drive is inside of your PC. Now let's move on to solid-state drive. Now, solid-state drives, or SSDs, use different construction altogether. There are no moving parts. They use arrays of flash-type memory instead of spinning platters to hold the data. You can achieve faster response times with an SSD than you could with a traditional hard drive. When an SSD is used internally, the most common interface is the SATA interface. When your solid-state drive is used externally, the connection type can vary. It can be USB, or it can be eSATA, or it could be FireWire. They are faster and quieter and cooler than the traditional hard drive, but the price per gigabit of storage is much higher than with traditional hard drive. So they're not going to replace the traditional spinning platter hard drive soon, at least not until the price comes down a bit. Now, some devices are a type of solid-state drive, but they're not really considered a solid-state drive. And what are those? Well, there's compact flash. Now, compact flash is a type of removable storage. It could be considered a solid-state drive because it holds data and there are no moving parts. Now, with compact flash, you can hold up to 128 gigabytes of data. Then there are secure digital cards, SD cards, with a current max capacity of 2 terabytes of data. We also have the older XD standard. Now this was used in some digital cameras to hold pictures, but is now considered obsolete. Now USB flash drives could also fall into the SSD category, but not really, because people think of them as their own category. Now that concludes this session on Storage Devices Part 2. We talked about the anatomy of a hard disk drive. We talked about some aspects of the traditional hard disk drive, and then we briefly touched on solid-state drive. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure another one will happen soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to the CPU. Today we're going to discuss CPU basics, Intel and AMD CPUs, and then we'll try and answer the question of which one is right for you. Now with that, let's go ahead and begin this session. So let's begin with some of the basics of the CPU. According to Moore's law, the number of transistors on an integrated circuit will double approximately every 2 years. This creates an exponential growth in the power of the integrated circuit. Now, Moore's law was introduced back in the 60s, and it still pretty much holds true for today's CPUs. So now let's talk about the central processing unit, the CPU. The first characteristic of it is speed. Now, speed typically is the frequency at which one core of the CPU operates. Currently, it's measured in gigahertz per second. The higher the number, the faster the core. Now let's talk about the cores. Now the cores are the actual CPU on a chip, on a silicon wafer. If a CPU is a multi-core CPU, then it actually has multiple CPUs on the same chip. The more cores, the more simultaneous tasks that can be accomplished. Then there's cache. Cache is expensive static random access memory that is located on the CPU die. All cache memory is much more expensive than regular dynamic random access memory, so not much of it is used. Cache is broken into 3 levels. L1 cache is typically embedded in each core of the CPU. L2 cache is typically located just off of the CPU or embedded into a coprocessor. L3 cache is still on the CPU die, but it's a little bit slower than L1 or L2 cache. Now let's move on to hyperthreading. Hyperthreading is the logical division of a CPU core. Through special instruction sets, the CPU is made to look and behave as if it had more than a single core. So you could have a 2-core processor that had hyperthreading, and it would actually behave like it was a 4-core processor. Some CPUs have virtualization support. When virtualization began, it always required fairly complex software and a host operating system. CPU manufacturers have now built virtualization support into some of their processors. This allows for easier and less complex virtualization. Some more modern CPUs are now coming with a GPU, a graphics processing unit, on the die. This allows for decent integrated graphics performance while not hindering the basic operation of the CPU. So you don't have to buy a graphics card and your CPU performance is not hindered by graphics rendering. Last but not least under the CPU basics is the architecture. Now this is either 32-bit or 64-bit. This deals with the amount of memory that a CPU can address, that is, keep track of. A CPU that has a 32-bit architecture can only address a maximum of 4 gigabytes of RAM, while a CPU that has a 64-bit architecture can address a theoretical maximum of 16.8 million terabytes of RAM. Man, that is just a ton of RAM. In actuality, the maximum amount of RAM that a 64-bit system can handle is established by the motherboard manufacturer. And before we leave CPU basics, let's talk about cooling. As a rule, the higher the performance of the CPU, the more heat it will generate. Excessive heat will kill or burn out a CPU. Heat is your enemy. To combat that, there are heat sinks. A heat sink is a device that is placed on top of the CPU. It usually has a solid metal base, but it transitions to fins towards the top. A heat sink will draw heat away from the surface of the CPU towards the top of the sink where it is radiated away into the case. To help improve the efficiency of the heat sink, we use thermal paste. It's a special compound that is used between the CPU and the heat sink. It fills in the microscopic voids that are present and will improve the connection between the heat sink and the CPU, thus improving the heat sink's performance. Fans are used to help radiate the heat away from the heat sink. They are designed to draw cooler air across the fins, thus transferring the heat away from it. And finally, there's liquid-based cooling. This works kind of like a car's radiator. The heatsink actually has liquid being pumped through it to draw heat away from the CPU. The liquid gets pumped to a radiator where the heat is dissipated. Now let's move on to Intel and AMD CPUs. We're going to start with Intel because they're the granddaddy. Intel currently uses Land Grid Array CPUs, LGA CPUs. The CPU does not have pins on the bottom of the chip. The pins are actually located in the CPU socket on the motherboard. The CPU just has corresponding contact points on the bottom of the processor. Intel processors are usually defined by their processor family, like Haswell or Ivy Trail, and their socket type. Some Intel socket types are the LGA 775, the LGA 1155, the LGA 1156, and the LGA 1366. There are many more Intel socket types, and more are being introduced all the time. Now let's move on to Intel's main competitor, AMD. Most AMD CPUs are pin grid array CPUs, PGA CPUs. The CPU has pins on the bottom that fit into holes on the socket. AMD's naming convention is also based on processor family and socket type as well. Some AMD socket types that you'll see are the 940, the AM2, the AM2 Plus, the AM3, the AM3 Plus, the FM1, and the F. As with Intel, this is not a comprehensive listing, plus there are more being created all the time. So let's talk about which one is right for you. Well, I can't really answer that question. The key to determining the correct CPU for you is research. Now, when you're researching the purchase of a CPU, you need to consider what you are trying to achieve, as well as any budgetary constraints. As a rule, the better the performance of the CPU, the more it will cost. And the newer the processor family is, the more it will cost. Also, in most situations, the software that is available today can't take advantage of the full capabilities of the CPU. So you may not want to buy the most cutting-edge current version. But as the processor's performance increases, they develop software to take advantage of more and more of those capabilities. So which CPU is right for you? I can't answer that for you. You're going to have to be the one to do the research. Now that concludes this session on the introduction to the CPU. We covered quite a few CPU basics. We talked briefly about Intel and AMD CPUs. And then I tried to answer the question of which CPU is right for you. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure you'll watch another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on interface connections. Today we're going to be talking about internal interface connections, external interface connections, and finally some other optional interface connections that you should know about. And with that, let's go ahead and begin this session. So let's start this session with internal interface connections. Now, before I dive into this, I should mention that an interface is a connection point. It not only involves that connection point, but it also quite often involves the cable that goes with it. And with that, let's begin with the first internal connection, and that would be the IDE. That is the Integrated Drive Electronics Interface. It used a 40-pin, 40-wire ribbon cable that could be up to 18 inches long, and it had 3 connections on it. 1 to connect to the motherboard and 2 for peripheral devices. The ends of the connectors were keyed so that they could only be inserted one way. Now, the IDE had a maximum transfer rate of 8.3 megabytes per second. IDE is closely associated with the Parallel Advanced Technology Attachment Standard, the PATA standard. Well, we found out that IDE just wasn't quite enough, so they came up with EIDE, the Enhanced Integrated Drive Electronics Interface. It used the same 40-pin connection that the IDE used, but it used an 80-wire ribbon cable. But it had the same physical dimensions as the IDE cable. Now, EIDE could achieve transfer rates of up to 167 megabytes per second. Man, that was a whole lot faster. EIDE is also backwards compatible with IDE. So now let's move on to SATA, Serial Advanced Technology Attachment. Now this is the interface that is replacing the IDE-EIDE interface in today's motherboards. It uses a 7-wire, 7-pin cable that has an L shape. Now that L shape means that it's a keyed connector and it can only be installed one way. Now this cable can be up to 1 meter in length. Now unlike the IDE and EIDE interface, only one SATA device is allowed per cable. But all SATA devices are hot swappable. That's of questionable value if your hard drive is a SATA hard drive and it's inside the case. Now SATA comes in 3 versions. There's SATA 1. It has a maximum transfer rate of 1.5 gigabits per second. Then there's SATA 2, and it has a maximum transfer rate of 3.0 gigabits per second. Then there's SATA 3, which has a maximum transfer rate of 6 gigabits per second. The other interface that you should be aware of is the eSATA, external SATA. Now this brings the high speed of the SATA interface outside of the computer case. Now it allows for a 2 meter long cable, and it can perform at SATA 3 level. Now that we're done with the internal interface connections, let's move on to the external interface connections. And we're going to begin with what's probably the most popular one, USB. The Universal Serial Bus Interface was introduced in 1998 and has been through several changes since it came out. The USB standard allows for chaining multiple devices together. You can chain up to 127 devices plus the controller. Now the USB interface can not only provide a data bus, but it can also provide power to run small devices. Now USB version 1.1 and USB 2.0 have a maximum cable length of 5 meters. But USB 3.0 does not have a maximum cable length, as long as the cable meets the electrical specifications. All USB standards are backwards compatible. Now let's talk about their speed. Now USB 1.1 has a maximum transfer rate of 12 megabits per second. USB 2.0 was a vast improvement. It had a maximum transfer rate of 480 megabits per second. And then we jump up to USB 3.0. Now this has a theoretical maximum transfer rate of 5 gigabits per second. For USB 1.1 and 2.0, the standard calls for different types of physical connectors. They can be broken out into A connectors and B connectors, with each having a mini and micro version. USB 3.0 has its own standard for the connector. And these are usually colored blue so that you know that they're a USB 3.0. Now let's move on to FireWire. Now the interface and standard were developed by Apple and introduced in 1999, and it has also been through several iterations. The FireWire connection was standardized by the Institute of Electrical and Electronics Engineers, the IEEE, as the IEEE 1394 standard. The standard allows for up to 16 devices to be chained together. The maximum allowable cable length is 4.5 meters. All the standards of IEEE 1394 are backwards compatible. There are 2 main standards. There's FireWire 400, which has a maximum transfer rate of 400 megabits per second. And then there's FireWire 800, which has a maximum transfer rate of 800 megabits per second. Moving on, we have the serial and parallel interface. These are the legacy standard for external peripheral devices. Most PCs no longer come equipped with these interface connections, having been replaced by the more versatile USB instead. Then there are the standard interfaces for connecting to external monitors. There's the VGA, DVI, and HDMI. That's the video graphics array, the digital video interface, and the high-density media interface. What is present on your PC will depend upon the graphics capability of that PC. Then there are RJ45s and RJ11s. These are the interface standard for twisted pair wires. Ethernet networking heavily relies upon the RJ45 interface, while the RJ11 is used with plain old telephone service, POTS. So now let's move on to other interface connections. These are non-wired interfaces. And we're going to begin with infrared. Now this is a line of sight interface only. The devices must be in visual range of each other. Now, it uses the infrared band of light to communicate between devices, and it had a distance limitation of approximately 3 feet. And by today's standards, it was fairly slow. It's not very common anymore. And then we have radio frequency, RF. Now, this encompasses various standards that involve communicating via radio waves. Your distance is limited by the power of the transmitting device, and your speed is limited by the standards that are employed. I'm not really going to get into that now. We'll get into that when we talk about wireless networking. Then we have Bluetooth. Now, this is a low-powered personal area network standard, a PAN standard, for creating a radio frequency connection. It operates on the 2.4 gigahertz radio frequency. It has an effective range of 10 meters, but the transfer rate drops as the distance between devices increases. Now that concludes this session on interface connections. We talked about some internal interface connections, some external interface connections, and some other interface connections that weren't wired. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on the Introduction to the Power Supply. Today we're going to be talking about alternating current versus direct current. Then we're going to be talking about the PC power supply itself, and then we're going to be talking about some things you need to consider when choosing a power supply. And with that, let's go ahead and begin this session. And we begin by talking about alternating current versus direct current. So let's start with alternating current, AC. The common source for AC is your wall socket, and the most standard unit of measure of AC is in volts. Now, we use alternating current because it's a better medium for transmitting power, especially over distance. Now, a characteristic of AC is that the electrical charge periodically reverses, which is represented by a wave. The reversal cycle is measured by the frequency of its change and is represented by its Hertz value, which is the number of cycles per second. Now, your most common voltages in the United States and Canada is 110 to 120 volts at a 60 Hertz cycle. The most common wall current in other countries is 220 to 230 volts at a 50 Hertz cycle. Direct current, DC, on the other hand, is usually either derived from converted AC power or from batteries. Direct current is a constant power. There is no reversal cycle. Now, DC works best for applications that need to store electrical charges, like a battery, or that require the constant power characteristic of DC, like computers. Computers require DC current. So talking about PCs, now let's talk about the PC power supply. So let's begin with the power supply's job description. It needs to take the AC wall current and change it to the appropriate direct current that the PC requires. And it needs to do so in the right amount. Not only does it need to supply the correct amount of DC current, but it also needs to supply it through the appropriate style of connector. Now, the common voltages that a PC requires are 3.3 volts, 5 volts, 12 volts, and negative 12 volts. Yes, I did say negative 12 volts. Now, power supplies are rated by the watts that they can supply. The watt is a unit of measurement for electricity. Watts can be determined if you know voltage and amperage. The formula for that is volts times amperage equals watts. So earlier I mentioned that the power supply needs to provide those voltages to the proper connectors. So let's talk about those connectors. There is the 24-pin main motherboard power connector, and it supplies 3.3 volts, 5 volts, 12 volts, and that negative 12 volt current that I talked about earlier. You use a 24-pin main motherboard power connector on most ATX form factor motherboards. There's also a 20-pin main motherboard power connector, and it supplies the same voltages that the 24-pin does. And this connector is for the micro ATX and smaller form factors. Today's CPUs tend to be a little bit more power hungry than in the past, and will require more power than what the motherboard can supply. That is where the 4 or 8-pin auxiliary motherboard power connector comes into play. Now it supplies additional 12-volt current for the CPU. You may also find the 4-pin Molex connector. This supplies 5-volt and 12-volt current, and it's used for some peripheral devices and for a lot of fans. There's also the Berg connector. That supplies 5-volt and 12-volt and was commonly used on floppy disk drives. You probably won't find too many Berg connectors on modern power supplies. Then there's the SATA connector. This supplies 3.3, 5, and 12 volts to SATA devices. It uses a 15-pin plug, and finally you may have a 6 or 8-pin PCI auxiliary power connector. This supplies additional 3.3 and 12 volts to some PCI add-on cards, specifically those that require it, which are commonly video graphics cards. Now let's move on to choosing a power supply for your PC. So the first thing that you need to do is you need to know the form factor. ATX, micro ATX, and ITX use different standard sizes for their power supplies. You cannot physically put an ATX power supply into an ITX case. It just won't fit. You also need to know your voltage requirements. Are you in the United States and Canada? Or are you most of the world? So do you need that 110 to 120? Or do you need the higher voltages that the rest of the world uses? Now, some power supplies can switch or be switched between standard voltages, but on the other hand, some cannot. You also need to know what is going on inside your case. What type of motherboard and CPU do you have? Do they need more power? What type of connector does the motherboard need? Also, the types and number of peripherals that you have inside your case will help to determine what kind of power supply you put inside that case. And along that lines, knowing your wattage requirements is beneficial. It's better to have more watts available and not need them than to need more watts and not have them. In other words, it's better to choose a larger power supply and have an abundance than to choose a smaller power supply and starve your system. Now that concludes this session on the introduction to the power supply. We talked about some of the differences between AC and DC power. We talked about the PC power supply itself, and then we talked about some things that you need to consider when choosing a power supply. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on custom hardware configurations. Today we're going to be talking about custom configurations for work and custom configurations for play. And with that, let's go ahead and begin this session. So of course we're going to begin by talking about custom configurations for the workplace. And we begin with the standard desktop, the thick client. Now they should meet the recommended hardware specifications for running the proposed operating system. Don't just meet the minimum specifications for the OS, or your users are going to be frustrated. The CPU should come from the mid to upper mid-range of the manufacturer's line of CPUs. For the RAM, your limitations are going to be caused by the operating system. A 32-bit operating system has a maximum RAM limit of 4 gigabytes, whereas a 64-bit operating system doesn't have that limitation. Now let's move on to the thin client. Now on a thin client, most applications and files are accessed and stored on servers, allowing the system to only need to meet the minimum requirements of the operating system. Even with that in mind, they should still also have enough capabilities to run basic applications. Now let's move on to a graphic or computer-aided design or computer-aided manufacturing workstation. This is a workhorse type system and should be built with power in mind. The processor should be more powerful and should come from the OEM's line that is designed for heavy workloads. They do have lines that are designed for workstations. These systems handle large files with a ton of data, so the maximum amount of RAM should be included with the system. These types of workstations also require at least one high-end or specialized video card in order to function properly. Moving on to the audio-video editing workstation, well, these are closely related to the design workstations that I talked about just a moment ago, with a couple of special considerations. Now, they require very large and very fast storage, especially for editing video. They also require specialized audio and video cards, and the video card or cards needs to be capable of driving at least 2 monitors. They still require more powerful processors and a lot of RAM. The virtualization workstation. Well, there are 2 keys here to this configuration, the CPU and the RAM. The CPU should come from the upper end of the power spectrum, and it should have as many cores as can be purchased and the client can afford. By the way, AMD's Optic series of processors comes with up to 16 cores. Now, the maximum amount of RAM, random access memory, needs to be included. This is because each individual virtual machine will be held by and operate within the RAM. So it's all shared between the virtual machines, so you need a lot of it. Now let's move on to custom configurations for play. And we start with the gaming PC. Modern gaming tends to be about the experience. It also has some specific requirements. The CPU in a gaming machine should come from the high end of the consumer market. And because of the nature of gamers, it should also be capable of being overclocked. Modern games tend to be very graphics intensive, so at the minimum, an upper tier graphics card should be included, or 2 or 3. Well, sound makes up part of the experience, so including a good sound card will enhance the gamer's enjoyment of the system. Gaming and gamers tend to tax the PC, and the harder you run it, the more heat that is generated. So installing increased cooling capacity is also often required. So how about the standard home PC? Well, in most cases, the home PC has the same requirements as the thick client from the work configuration. Now let's talk about the home theater PC. In most home theater PC applications, the CPU and RAM only play a minor role, so their importance is minimized. This allows you to use a smaller form factor like an HTPC or an ITX-based system, which allows you to use a low-powered CPU, and you might not even need to install fans, which is often a requirement of the home theater PC. These systems do need to have improved audio capabilities, so you want to install a sound card that offers surround sound. They also require a TV tuner card. And finally, for best results, the home theater PC should have at least one HDMI output to drive a television. Now let's move on to the home server PC. It's often used for media streaming and file sharing. The CPU requirements are fairly minimal for this type of application. It's more important to have more RAM than a powerful CPU. The home server PC, especially when it's being used for media streaming, usually requires more and faster storage. Large, fast hard drives should be included. To improve your throughput for a media streaming PC, you might want to consider bonding multiple Ethernet channels to the network. This will increase your bandwidth from the media streaming PC. Now, the key to building any custom configuration is to understand what it's going to be used for. Be sure and talk with your clients to fully understand what their intended purpose is for that PC. You need to understand what is important to them. Also be sure that you and the client know what the budget for the project is going to be. You don't want to go over budget. You should also strive to make the system as future-proof as you possibly can and still remain within the proposed budget. Now that concludes this session on custom hardware configuration. We talked about custom configuration for the workplace, and we talked about custom configurations for play. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on display devices. We're going to be talking about pixels and lumens. We're going to be talking about analog and digital displays, and then we're going to talk about types of display devices. There's a whole bunch of material to cover, so let's go ahead and get started. So let's start with pixels and lumens. I'm sorry, this is about pixels, not pixies. Now, pixels is a word that's made up out of picture elements, and it represents a basic programmable unit of color on a display device or computer image. In the modern display device, the pixel is a 24-bit block that is composed of 1 byte units of red, blue, and green, RGB. All the colors of the spectrum are composed by combining various intensities, byte values, of the color component. The pixels are combined and the image is formed. The more pixels that are present, the sharper the resolution. Now, resolution is a method of establishing how many pixels wide and tall an image is, which has an effect on the sharpness of the image. Pixels are logical in nature, which means that their size is not a set standard. In most cases, you, the user, can determine the resolution of the display. Now let's move on to lumens. Lumens are one measurement of light output or brightness. The more lumens that are present, the more light that is output. Some display devices are rated for more lumens than others, which can have an impact on where they are deployed. For instance, a display device that doesn't have a very high lumen count will not perform very well in a situation where there is bright ambient lighting. Now let's move on to analog versus digital displays. So let's begin with analog type displays. An image is created digitally inside the PC and delivered to the graphics device. The graphics card or the onboard PC graphics. The graphics device converts the image from its native digital format into a modulated electrical current format, that's analog, that is then delivered to the display. The display uses the analog format to represent the image on the screen. Analog screens tend to be slower in processing images on the screen. Now, many digital displays can receive an analog signal, which they then convert back into a digital format. Now let's talk about digital. A digital image is created and delivered to the graphics device. The graphics device transmits the image to the display device in its native digital format. The display device receives the digital image and represents it on the screen. It is the newer standard and tends to be faster than analog. Now let's move on to types of displays. And we start with the CRT, the cathode ray tube. Now this is an older standard. A CRT monitor uses a combination of a vacuum tube, an electron gun, and a fluorescent screen. It is analog in nature. The electron gun excites the individual pixels on the fluorescent screen, which then light up and present the image. Each line on the screen needs to be refreshed because the screen doesn't hold the electrical charge. The rate at which this is done is called the refresh rate. Too low of a refresh rate will cause the screen to flicker and cause eye fatigue. Now, CRT monitors tend to have very good color representation, and it's easy to adjust the resolution and get a good sharp image. Now let's talk about projectors. With projectors, the output from the PC is sent to the projector, which then transmits the image to a screen or wall. Now, projectors can either be analog or digital. The amount of lumens that the projector is rated for is important, as it will affect the amount of ambient light that can be present and still allow for the projected image to be seen easily. Now let's talk about the LCD display, the liquid crystal display. Now this is a type of flat panel monitor that uses an arrangement of liquid crystals and a fluorescent backlight to place an image on the screen. The liquid crystals are sandwiched between layers of glass and make up the screen that you see. An electrical current is used to change the alignment of the crystals, which then refract the fluorescent backlight, giving us the colored image. The liquid crystals do not emit any light by themselves. The light we see is actually coming from the fluorescent backlight. Because of this, LCDs do not do very well in bright environments. LCDs are a digital technology. Now, LCDs do have a native resolution for the screen. That is a pixel count that produces the best image. You can change the resolution, but you run the risk of distorting the image. With an LCD, the whole screen gets refreshed simultaneously, not line by line. LCDs are faster and consume less electricity than CRTs, but the color representation is not as good as the CRT. Now let's talk about LED displays. That's a light-emitting diode. LED displays operate exactly the same as LCD displays, except for one item. The LCD's fluorescent backlight is replaced with an LED backlight. Other than that, they are exactly the same. Now let's talk plasma displays. Now, plasma is a flat panel display technology that uses fluorescent cells contained in the screen. There's millions of them. An electrical charge is used to excite the cells and causes them to fluoresce in different colors, which causes the image to appear on the screen. This technology does not require the use of a backlight. Plasma displays work okay in brighter ambient light levels. It is also a digital technology. The plasma display does have a native resolution. Now, it does require higher voltages than the LCD or LED monitor. It also tends to be more expensive than LCD and LED monitors, but it also produces much better color than those two. It actually produces color on par or better than the CRT. Now let's move on to OLED monitors. That's organic light emitting diode monitors. Now this is an emerging display monitor technology. OLED is closer to LCD LED technology than it is to plasma technology. Instead of liquid crystals, the screen is composed of diodes that are sandwiched between thin layers of glass. An electrical charge is used to light up the diodes, which then place the image on the screen. OLED displays are thinner, lighter, and consume less energy than any other type of display. Except for the cell phone market, organic light emitting diode display technology has not spread very far because of the cost of creating the monitors. The yield for the displays is very low, so they're difficult to make, which drives up the cost. Now that concludes this session on display devices. We talked about pixels and lumens. We talked about the difference between analog and digital displays, and then we talked about various types of displays. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on cables and connections. Today we're going to be talking about internal cables and connections, then we're going to talk about external cables and connections, and then we have a special category, display device cables and connections. And with that, let's go ahead and begin this discussion. And of course, we're going to begin by talking about internal cables and connections. And we start with the truly ancient, the floppy disk drive cable and connection. Now the FDD cable has 34 wires and it has 34 pins on the connection. You can connect up to 2 floppy disk drives per cable, with the higher priority going to the device that connects after the twist in the cable. That would be your A drive. Then we move to the PATA cable and connection, the parallel AT attachment. Now PATA has 2 basic standards, the Integrated Drive Electronics, the IDE, and the Enhanced Integrated Drive Electronics, the EIDE. Now the IDE cable contains 40 wires and the connector has 40 pins. Up to 2 PATA devices can be connected per cable, with the priority for the device being set by jumpers. Now an EIDE cable looks very similar to an IDE cable, but it contains 80 wires, but it still has a 40-pin connector. It is backwards compatible with IDE, but it allows for higher throughput. Both IDE and EIDE have a maximum cable length of 18 inches. Now moving on to more modern standards, we have the serial AT attachment, the SATA cable. Now this cable contains 7 wires with 7 pins. Only one device can be connected per cable, with the priority for SATA devices being set in the BIOS. The connector is L-shaped, so it can only be inserted one way. That's a keyed connector. Now let's move on to external cables and connections. Following the same pattern, we're going to begin with the old and work our way towards the new. And we begin with the serial cable and connection. The most common cable and connection is the 9-pin connector. This connector is often called a DB9, or it's often called an RS-232 connector. That's after the RS-232 serial communication standard. Then there's the parallel cable and connection. The most common cable and connection is the 25-pin connector, and guess what it's commonly called? It's commonly called a DB25. Then we have the PS2, the Personal System 2 connection, which can also be called a mini DIN6 connection. It was most often used to connect a mouse and or a keyboard to the PC. In most cases, the in not connected to the PC was hardwired into the actual device. It uses a keyed 6-pin connector. Now you'll be hard-pressed to buy a modern PC that has a PS2 connection. Now let's move on to the Small Computer System Interface, the SCSI interface. SCSI is a standard that involves how peripheral devices communicate with the PC. It's been around for a while, so it's been implemented through various cables and connections. The most common cable used in implementing SCSI is a ribbon cable that has 2 or more connections on it. The most common SCSI connectors are the 68-pin, the 50-pin, and the 25-pin connection. You need to know what your device and interface is when you are installing SCSI. Now let's move on to sound connections. In most cases, the connection to speakers, microphones, and subwoofers is made through a cable that plugs into jacks on the back of the PC, providing an analog audio sound. And what that means is that each cable carries a single sound channel. The jacks and the connector are called tip ring sleeve connectors, TRS connectors. Another type of sound connection is the Sony Philips Digital Interface Format, the SPDIF connector. These can come in slightly different forms, but they all do the same thing. They will provide digital sound over a single cable. Now let's move on to network connections, and we begin with the registered Jack 45, the RJ45. It is the most common modern connector for Ethernet networks. The RJ45 uses an 8-pin modular connection with up to 8 wires being used as conductors. This is technically called an 8P8C modular connection, and it's used to transmit data over the network. Now the RJ11 is the most common connector for telephoning, and it's often used when networking over telephone wiring, or for when you're making telephone calls. The RJ11 uses a 6-pin modular connector with up to 4 wires being used as conductors. Technically, that's a 6P4C modular connector. Now, coaxial cabling can also be used to make a network connection, but it's not very common in today's local area network environment. So let's talk about USB versions 1 and 2. That's the Universal Serial Bus Connector. Versions 1 and 2 use the same cables and connections. The basic types of connectors are broken out into Type A and Type B connectors. Type A USB connectors can carry power to the peripheral device as well as carrying data. Type B connectors do not provide power to the peripheral devices. The maximum length of a USB cable is 5 meters. So now let's talk about USB 3. It's a newer, higher speed version of the Universal Serial Bus. USB 3 devices use a different type of connector for peripherals. They're specific to USB 3. Earlier USB peripheral devices can use standard USB cables to connect to a USB 3 port on the PC. The USB 3 port on the PC is usually colored blue to differentiate it from earlier versions of USB. Now, as long as the cable matches the electrical specification, there is not a maximum length for USB 3 cables. Let's move on to the IEEE 1394 cable and connections. This is FireWire. Now, FireWire comes in two current standards. There's FireWire 400, which uses a 6-conductor cable with a maximum length of 4.5 meters. Then there's FireWire 800. It uses a 9-conductor cable and has a maximum length of 4.5 meters as well. Now, a connection that you might come across on a PC is the eSATA connection, the external SATA connection. This is a standard that brings the speed of SATA outside of the PC's case. Now, an eSATA port is a type of combination port. It combines a USB port with a SATA port. Now, it has not been approved by the organization that sets the USB standards, and it has not been approved by the organization that sets the SATA standards. So use an eSATA port at your own risk. So now let's move on to display device cables and connections. And we're going to begin with analog cables and connections, and the first one up is the composite RCA cable. Now, this looks like a TRS cable, but it can carry an analog video stream. The end result is the lowest level of resolution that you can deliver to a monitor. Slightly better is the S-video cable. It is a 4-pin cable that has better resolution than a composite cable, but still not very good resolution. Moving onward and upward, we have the component or RGB cable. Now, this is a combination of 3 cables. It breaks the color components of the video stream into 3 discrete channels. This allows for better resolution than S-video and composite. And finally, we have the VGA, the Video Graphics Array, which can also be called a DB15 or an HD15. Now, this is an analog display standard that uses a 15-pin D-subminiature connector. That's the DB15 connector. The pins are arranged in 3 rows of 5, which are fitted into a D-shaped shell. Now let's move on to the digital world, and we begin with DVI cables and connections. That's the Digital Visual Interface. Now, this is designed to carry an uncompressed video stream, which results in a superior image. Now, DVI comes in different versions. There's DVI A. It can only carry an analog stream. Then there's DVI D, and it can only carry a digital stream. To kind of bridge the gap, DVI-I was developed. It can carry either a digital or analog stream. Then we have the High Definition Multimedia Interface, HDMI. It too is designed to carry uncompressed digital video, but it can also carry audio at the same time through the same cable. It provides for a high transfer rate and with a very high quality image. It comes in 2 standards. There is the full-size HDMI, and it uses 19 pins. Then there's the mini HDMI. That's a smaller format, but it still contains 19 pins. Now, it's not as robust as the full-size HDMI, which means that it's easier to break. And finally, we have the display port. Now, this is a non-proprietary standard for transmitting high-quality video from a device to a display. It uses a 20-pin connection. Now, DisplayPort comes in various sizes, depending upon the form factor of the device that is transmitting or receiving the stream. Now, that concludes this session on cables and connections. We talked about internal cables and connections, then moved on to external cables and connections, and we ended up on display device cables and connections. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on peripheral devices. Today we're going to talk about what are peripheral devices, how peripheral devices connect to a PC, and then we will briefly touch on some examples of peripheral devices. With that, let's go ahead and begin this session. So, what are peripheral devices? Well, peripheral devices are not built into the computer. They are external to the system. They have a connection to the PC, either via a wired connection or via a wireless connection. They have a main purpose, to improve output, to improve input, to extend functionality, to increase productivity, or to expand the enjoyment of the system. Now, peripheral devices use device drivers. Device drivers tell the host operating system how the peripheral device is supposed to interact with the system. The device drivers will also tell the operating system how peripheral devices will interact with each other. The manufacturer of the peripheral device is the one who provides the driver to the operating system or to the user. Now let's move on to how peripheral devices connect to the PC. And we'll start with legacy connections. They can connect through a serial port, the DB9. That is a D-shell 9-pin connection. Or they can connect through a parallel port, the DB25, a D-sub miniature 25-pin connection. Most modern systems do not come with a serial port or a parallel port anymore. You need to be aware of that just in case you buy a peripheral that requires that type of connection. So let's move on to a semi-legacy type connection, and that would be the PS2 connection, the Personal System 2 connection. These are a keyed 6-pin connector, commonly used for keyboards and mice. Again, these are a little bit harder to come by on modern PCs. So what are more current standards? Well, there's the Small Computer System Interface, SCSI. You can still find those. There's USB. There's IEEE 1394, commonly known as FireWire. There's wireless connections, Bluetooth. There's network connections, Ethernet. There's tip ring sleeve, TRS connectors. Those are analog sound connectors, by the way. There are a whole bunch of ways that peripherals can connect to the PC. Now, the manufacturer of a peripheral device may require a proprietary connection type. When they do, they will also provide the means of accomplishing that connection to the PC. So when you're connecting a peripheral device to a computer, always read the manufacturer's installation instructions first. The major reason for that is to determine when the device driver gets installed on the PC. Some operating systems and peripheral devices are very peculiar about some driver installations. Installing the driver in the incorrect order can result in frustration due to loss of functionality. Now let's move on to some examples of peripheral devices. There are input devices, keyboards and mice, the KVM, which is a keyboard video and monitor switch. There are scanners and barcode readers, biometric devices, gamepads and joysticks, microphones, digitizers. Those are used for capturing an analog signal in a digital format. Then there are output devices like speakers, printers, and display devices. And finally, there are multimedia devices, digital cameras, camcorders, and webcams. There's also MIDI, the Musical Instrument Digital Interface, which has a whole bunch of different multimedia devices that can connect to it. Now that concludes this session on peripheral devices. We talked about what peripheral devices are. We talked about how peripheral devices can connect to a PC, and then we ran through some examples of peripheral devices. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the basics of network cable connections. Today we're going to be talking about fiber optic network connections. We're going to be talking about coax network connections, and we're going to conclude on twisted pair network connections. I have a whole bunch of information to cover, so let's dive right in. So let's start with fiber optic network connection. The fiber optic cables themselves are composed of one or more strands, fibers, of high-quality glass or plastic. The strands are coated with a sheath, that's called cladding, that aids in the transmission of a light signal down the fiber. There are three common types of network connections for fiber optics. There's the SC connector, the square connector, or subscriber connector. There is the ST connector, the straight tip. And then there is the LC, which is also known as the lucent or little connector. Now, when fiber optics are used in networking, each network connection is actually a pair of fiber optic cables. One cable is used to receive network traffic, and the other cable is used to transmit network traffic. This allows for duplex communication. Now let's move on to coax network connections. A coax cable is composed of a central conductor that is covered with an insulating layer that is covered with a metal mesh or foil sheath, which is finally covered by an insulating layer. The ends of a coax network cable are required to be terminated with a resistor to eliminate signal bounce. In today's networking environment, about the only connector you'll come across is the F connector. It's a simple, rugged connector, and they're used with RG6 or RG59 coaxial cable. Less common, but you may still find it, is the BNC, the bayonet Neil-Councilman connector, or bayonet nut connector. This is an older technology, like I said, and it really isn't used in the modern network, at least hopefully not in your network. So let's move on to twisted pair wire network connections. Now, twisted pair wire is the most common of all networking cables. The cable is composed of 8 wires that are twisted together into pairs. The rate of twist in each pair is slightly different to reduce the chances of interference, called crosstalk, from the adjoining pairs. It also reduces the opportunity for electromagnetic interference, EMI. Now, there may or may not be a shield around each pair of wires and/or a shield around all 4 pairs of wires. Well, that's true. All 4 pairs of wires are housed in a common sheath. Now let's talk about the common twisted pair network connections. First up is the RJ45, the registered jack 45. This is the network connector that most people think about when they think about Ethernet networking. It's a modular network connector that contains 8 pins and will accept 8 conductors wires. An RJ45 can also be called a modular 8P8C connector. That's 8 pin, 8 conductor connector. The other common twisted pair network connector is the RJ11, the registered jack 11. Like I said, this is also a common network connector, but most people don't think of it that way because it's used for telephones. It is a modular network connector that contains 6 pins and 4 wires. It is a modular 6P4C connector. So let's talk about the twisted pair wiring standards. There are 2 twisted wire cable pinout standards, that's wiring standards, that are regulated by the TIA EIA, that's the Telecommunications Industry Association Electronics Industry Alliance. The pinout standards specify the ordering of the wires to ensure that proper networking communication can take place. The two standards are the TIA EIA 568A, that's the T568A standard, and the TIA EIA 568B or T568B standard. And you can see that the pinouts are slightly different. When you're working with twisted pair cable, there are some common tools that you should have. First up is the wire stripper. These are used to remove the insulating jacket from the twisted pair cable. Then there's the crimping tool. These are used to secure the wires into the modular connector, into the RJ45 or the RJ11. You should also have a punch down tool. Now these are used to secure the wires into a punch down block, which is a fairly common component in the modern local area network. And finally, you should have a cable tester. These are used to test the integrity of the network cable to make sure that it's good. Now that concludes this session on the basics of network cable connections. We talked about fiber optic network connections. We briefly talked about coax network connections, and we ended on the twisted pair wire network connections that are available to you. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on coaxial and fiber optic network media. Today I'm going to be talking about coaxial network media and fiber optic network media. We have a bunch of material to cover, so let's dive right in. And we'll begin by talking about coaxial network media. Now, coax is one of the oldest Ethernet cabling standards. It has been used for baseband, that's carrying a single digital signal. It's been used for broadband, carrying multiple digital signals. The coax cable is composed of a central conductor that is covered by an insulating layer, which is covered by an outer metal mesh that is finished off with an outer insulating layer. The inner metal mesh or foil layer helps to protect against electromagnetic interference. Now, coaxial cabling requires that the ends of the cable be terminated by some kind of resistor in order to keep the signal from bouncing back down the cable. The value of the resistance required is measured in ohms and is called the impedance value. There are two impedance standards used with coax. There's the 50 ohm and the 75 ohm. In most cases, the equipment that's attached to the end of the coax has the resistor built into it, but not always. You need to know that if you're working with coaxial cabling. Now let's talk about coax cable specifications. Coax is broken out into different categories based on its physical characteristics, such as the size of the conductor, the size and composition of the inner insulation layer, and the impedance value. These specifications are detailed in the radio guide tables. Now, the RG tables were a specification developed by the U.S. military. They no longer use it, but we still use the RG specifications to talk about coax. Now, what are some common coax standards? Well, there's RG58. It is used for 10 megabits per second networking. That's 10 base 2 networking. Now it can span up to 185 meters and it has an impedance value of 50 ohms. Then there's RG8. It was used for 10 megabits per second networking as well, only that was 10 base 5 networking. It could span a distance of up to 500 meters and it too had a 50 ohms impedance value. RG11 was also used for 10 base 5 networking, and it too could span up to 500 meters and had a 50 ohms impedance. Last up, we have what you'll find in most cases, which is RG6. Now it's used for cable television or broadband. The distance that RG6 can span varies, but it has an impedance value of 75 ohms. You will still find RG6 used today. Now let's move on to fiber optic network media. So let's talk about fiber optic cabling. Now, fiber optic cabling is composed of small, very clear glass or plastic tubing that is coated with an outer covering that's called cladding. Network traffic is carried by a light beam that is transmitted down these fibers. The source of the light is either an LED or a laser diode. Fiber is a high bandwidth media carrier. That means it can carry a lot of data, and it's capable of carrying that data over large distances without the use of a repeater. Fiber optic network media is not affected by electromagnetic interference and is a lot harder to intercept mid-transmission than other types of media. But fiber optic cabling is relatively expensive and harder to work with than other types of network media, with the end result being that it's not used very often in the local area network, but can often be found in the wide area network environment. In most networking applications, if you're going to use fiber optic cabling, you need to use two. One cable to transmit data and one cable to receive it. Fiber optic cabling is usually categorized by its transmission style and its core size, as well as the size and type of cladding that it uses. So let's talk about those fiber optic classifications. The first thing that you need to know is that fiber optic cables are classified initially by their types of transmission. And those types of transmission are multimode fiber, MMF, which uses an LED as the method of transmitting the light down the cable. And then there's single mode fiber, SMF. It uses a laser diode as the method of transmitting light down the cable. Now, these fiber optic cables are subclassified even further based on the size of their core and the thickness of the cladding, both of which are measured in micrometers. So what are some common subclassifications? Well, for MMF, there's 50/125. Then there's 62.5/125. The classification for single mode fiber typically varies with the core size, and it has core sizes ranging from 8 to 10.5 micrometers. And it usually comes with 125 micrometer cladding. So let's talk about the difference between MMF and SMF. Now, MMF uses an infrared LED system to transmit the light signal. It sends multiple rays of light down the fiber. MMF is used for shorter runs. You cannot exceed 2 kilometers. It is less expensive to implement than single mode fiber. And the most common application in networking utilizes MMF 62.5/125 cables, and the maximum span that those can run is 275 meters. Now let's talk about single mode fiber. It uses a laser diode arrangement to transmit the light signal, and it sends a single ray of light down the fiber. The advantage of single mode fiber is that it can be used for longer runs. It can traverse up to 40 kilometers without using a repeater. So now let's talk about some common fiber standards. There's 1000 base SX. That's 1 gigabit per second networking, and that runs on multi-mode fiber up to 500 meters. We also have 1000 base LX, 1 gigabits per second networking on single mode fiber up to 5 kilometers. Then there's 10G base SR. That's 10 gigabits per second networking on multi-mode fiber up to 300 meters, and it uses a local area network type connector. There's also 10G base SW, 10 gigabits per second networking on multi-mode fiber, and it can span up to 300 meters, but it uses a wide area network type connector. Then there's 10G base LR, 10 gigabits per second networking on single mode fiber. It can span up to 10 kilometers, and oddly enough, it comes with a local area network type connector on the end of it. Then there's 10G base LW. That's 10 gigabits per second networking on single mode fiber, and it can span up to 10 kilometers and uses a wide area network type connector. And then there's 10G base ER, 10 gigabits per second networking on single mode fiber up to 40 kilometers with a LAN connector. And finally, there's 10G base EW. That's 10 gigabits per second networking on single mode fiber spanning up to 40 kilometers using a wide area network connector on the ends of it. Now, something to keep in mind is that if the standard has an S in it, as in SX, SR, SW, those are multi-mode fiber. The S stands for short. If it has an L in it, as in LX, LR, LW, that's single mode fiber of up to 10 kilometers. And finally, if it has an E in it, ER, EW, that stands for extended. And that's single mode fiber of up to 40 kilometers. Now that concludes this session on coaxial and fiber optic network media. I talked about coax network media and we discussed fiber optic network media. Now on behalf of PACE IT, thank you for watching this session and I look forward to doing another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Twisted Pair Network Media. Today we're going to be talking about twisted pair network cables, and then we're going to be talking about some categories and characteristics of twisted pair. And with that, let's go ahead and begin this session. So let me begin by introducing you to twisted pair network cables. So most people are familiar with twisted pair cables. Why? Because they are the standard in the local area network. They are the Ethernet cables. Twisted pair network cables are constructed from 4 pairs of wiring contained within an insulating sheath. Each pair of wire is twisted together with a slightly different twist rate. This twist in the pairs reduces the opportunity for electromagnetic interference from outside sources or from other pairs of wires. Now, this interference that can be caused by adjacent pairs is called crosstalk. Each pair of wires is color-coded with the common coloring scheme being white, orange, orange, white, blue, blue, white, green, green, and white, brown, brown. Now these twisted pair cables can be either shielded or unshielded. That's STP or UTP. Now shielded twisted pair has an additional shield that is either wrapped around each pair of wires or around all 4 pairs. STP reduces the opportunity for EMI or crosstalk, but it is a little bit more expensive and a little harder to work with. The shielding reduces the flexibility in the cable. Now, UTP, unshielded twisted pair, is deployed in the network much more often than STP is. Now, UTP and STP can come in plenum grade or non-plenum grade twisted pair. Building codes often call for plenum grade cable, to be run in the plenum space. Now, the plenum space is an area that is designed to assist in the airflow of a building for HVAC purposes. In a plenum cable, the outer jacket is either made from a fire retardant cover or a low smoke PVC material. This outer cover makes these cables a little less flexible and more expensive. Quite often, plenum cables have a polymer or nylon strand woven into them. This helps to take some of the hanging weight of cables. This reduces the chance for cables to stretch, which can cause the pairs of wires inside to break. Now let's move on to some characteristics and categories of twisted pair. A twisted pair network cable is designated as either being a straight-through or a crossover cable. A straight-through cable is a cable in which the wiring scheme is the same on both ends. That wiring scheme is called the pinout. They are used to connect dissimilar types of devices, like a PC to a switch or a switch to a router. The crossover cable, on the other hand, uses a different pinout on the cable ends. They are crossed over from end to end. The crossover cables are used to connect similar types of devices, like when you need to connect a PC directly to another PC or a switch to a switch. Although now it is common for the network ports to be able to auto-sense what they connect to, and they can make the switch internally. Now, twisted pair can have different types of conductor construction. They can have a solid conductor. That's where the core of each wire is made from a solid copper conductor. These are strong and sturdy, and they work really well for pulling twisted pair through walls. But there are two things with solid conductor cables. They have reduced flexibility, and they tend to be more expensive. The other type of construction is stranded conductor. The core of each wire is made from small, thin strands of copper that are twisted together. They're not as strong or as sturdy as solid core wire, but they're much more flexible than solid core, and they work really well for patch cables. Now let's move on to categories of twisted pair network media. Twisted pair network cables are broken out into categories based on their maximum rated ability to handle network traffic. Most of the bandwidth gains in the categories are due to the changes in the twist rate in the pairs. More twists in a pair of wires reduces EMI and crosstalk, allowing for more speed across that pair. There are currently 5 different categories of twisted pair network cables that are readily available. There's Cat 3, Cat 5, Cat 5e, Cat 6, and Cat 6a. Unless otherwise specified, the maximum distance a twisted pair cable segment can span is 100 meters. Now let's move on to those categories of cables in a little bit more in depth. And we begin with Cat 3. Now this is rated for up to 10 megabits per second in speed. That's 10 base T networking. It's not really used in the LAN anymore, in the local area network, but it is still used for telephoning, for running telephone lines. Cat 3 was replaced by Cat 5, which is rated for up to 100 megabits per second in speed. That's 100 base T networking. Cat 5 couldn't keep up with modern networking, so along came Cat 5e. It's rated for up to 1 gigabits per second, that's 1000 base T networking. And of course technology moves on, so we had to come up with Cat 6. It's rated for up to 10 gigabits per second, that's awfully fast by the way. That's 10 GBE or 10 gigabit Ethernet networking. Now to achieve that 10 gigabits per second speed, your maximum cable length on a Cat 6 cable could only be 55 meters. Well, they'd found that wasn't quite long enough, so they came up with Cat 6A. Now it has the same rating as Cat 6, but your segment can be up to 100 meters long and still achieve those 10 gigabit Ethernet speeds. Now that concludes this session on twisted pair network media. We talked about twisted pair network cables, and then I went into some characteristics and categories of twisted pair. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's Introduction to IPv4 Part 1. Today I will be introducing you to IPv4, and then I will be talking about IPv4's address classes. There's a whole lot of material to cover, so let's go ahead and begin this session. And I'll begin by introducing you to IPv4. Internet Protocol version 4 is a binary addressing scheme that is used for networking. It was finalized as a standard in 1981. Now, IPv4 is the most common and popular network addressing scheme that is out there today. There is an issue with it, though. Because of its structure and the growth and popularity of the Internet, most of the world has run out of assignable IPv4 addresses. But thanks to some forethought and some special mechanisms, it's still a valid scheme today. Now, IPv4 works at layer 3 of the OSI model. Layer 3 of the Open System Interconnection model is the network layer, and its major focus is on logical network and host addressing. IPv4's job is to provide the logical network and host addresses. And it does this extremely well. IPv4 is a 32-bit binary addressing scheme. The 32 bits are broken down into 4 octets, which can be represented by zeros and ones. Of course, that's what binary is. For human readability, it is represented in a format that is called dotted decimal. There are theoretically 4,294,967,296 possible individual IPv4 addresses. Binary numbering uses base 2 counting, which means that every bit that is present represents an exponential growth in the value that is being represented. So with IPv4 being a 32-bit number, the possible maximum value is equal to 2 to the 32nd power, which is why there are over 4 billion possible IPv4 addresses. Now let's move on to IPv4's address structure. Some of the bits make up the logical network address. Think of your own physical address. And some of the bits make up the logical host portion. Think of a letter that is addressed to you at your physical address. Now each address in IPv4 needs to be unique if routing is going to occur. Now, a device called a subnet mask is used to determine which portion of the IPv4 address is for the network and which part is used for the host. So now let's talk about the subnet mask. It is also a 32-bit binary number. It can use 2 methods of being represented: dotted decimal like a normal IPv4 address, and the CIDR format, classless interdomain routing format. If the subnet mask is used, it's applied bit by bit from left to right. And here's what I mean by that. The subnet mask 255.0.0.0 is applied left to right to the IP address. By the way, if that was represented in CIDR, that 255.0.0.0 would be represented by a /8. Any portion of the IPv4 address that is covered by the ones in the subnet mask make up the logical network portion of the address. The other portion makes up the host address. So with that IPv4 address that we have there to the right, the network address would be, well, network 24, and the host address would be 113.185.118. Now that we have that covered, let's move on to IPv4's address classes. IPv4 has been divided into classes of addresses. There's Class A, Class B, Class C, Class D, and Class E. Now you only really need to know about classes A through D, so let's cover those now. Now a Class A address always has a subnet mask of 255.0.0.0. This gives us 256 possible Class A networks. The first octet on the left always begins with a 0. So that means that the first bit of the left-hand octet always begins with a 0. That gives us a possible address range of 0.0.0.0 to 127.255.255.255. Then there are Class B addresses. These always have a subnet mask of 255.255.0.0. This gives us 65,536 possible Class B networks. The first octet on the left of a Class B address always begins with a 10. So the first 2 bits are always 10. This gives us a possible address range of 128.0.0.0 up to 191.255.255.255. Then there are Class C addresses. These always have a subnet mask of 255.255.255.0. This gives us over 16 million possible Class C networks. The first octet on the left always begins with a 110. So the first 3 bits of the left-hand octet are always 110. This gives us a possible Class C address range of 192.0.0.0 up to 223.255.255.255. Now we're almost done, but let's talk about Class D addresses. Now these do not have a defined subnet mask. That's because they are a special class of addresses. Specifically, they're used for multicast network transmissions. The first octet on the left always begins with a 1110. So the first 4 bits of that left octet are always 1110. It has a possible address range of 224.0.0.0 up to 239.255.255.255. Now, I did mention briefly Class E addresses. Currently, those are just being used for research, so you don't need to know about those at this time. Now, that concludes this session on the introduction to IPv4. I started by introducing you to IPv4, and then I moved on to IPv4's address classes. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Introduction to IPv4 Part 2. Today we're going to be talking about public versus private IP addresses, and then I'm going to talk about automatic private Internet Protocol addressing. There's a fair amount of material to cover, so let's go ahead and begin this session. So let's start by discussing some of the differences between public and private IP addresses. Now, because of its structure, IPv4 gives us over 4 billion possible addresses, and all IPv4 addresses need to be unique on their network. So without some special mechanisms in place, all IPv4 addresses would be public addresses. Now, public addresses are routable, meaning that they can traverse the internet. Each public IP address is unique on the network. That means it's unique on the internet. If all IPv4 addresses were public, the IPv4 address pool would have run out long ago. So they developed some special mechanisms to help conserve that pool. And that particular mechanism that conserves the pool is private IPv4 addressing. Private addresses are non-routable, meaning the address cannot pass through a router's interface. Private IPv4 addresses are only relevant to their own local network. So now let's talk about how we get those private IPv4 addresses. There are 3 main pools of private IPv4 addresses. The network administrator is responsible for determining which of those pools is used on the local network. So now let's talk about those 3 pools of private IPv4 addresses. First up, there's 10.0.0.0 up to 10.255.255.255. Now you can use this with a minimum subnet mask of 8 bits. By default, it provides a single Class A network with over 16 million host addresses. The second pool that's available is 172.16.0.0 up to 172.31.255.255. Now this can be used with a minimum subnet mask of 12 bits. By default, it provides 16 Class B networks with over 1 million host addresses available in each network. And then the final pool is 192.168.0.0 up through 192.168.255.255. Now this can be used with a minimum subnet mask of 16 bits. By default, it provides 256 Class C networks with 65,536 addresses available for hosts. And there you have the 3 pools of private IP addresses that are available in IPv4. These have extended the life and usefulness of IPv4 for years. Now let's move on to automatic private Internet Protocol addressing. Now before I get into a PIPA, we need to talk about methods of assigning IP addresses. There are three main methods to do this. Manually, the network administrator assigns each host with its own address. The second method is automatically from a service, specifically Dynamic Host Configuration Protocol, DHCP. A DHCP server is configured with all of the information needed for a network host to join a specific network. And finally, we have automatic private Internet Protocol addressing. This is where the host automatically assigns its own IPv4 address using a PIPA. It self-selects its address. So let's talk about this address. The PIPA address pool ranges from 169.254.0.1 up through 169.254.255.254. The PIPA address can also be called a link local address. Hosts that receive these addresses can only communicate with other hosts who have PIPA addresses. When an PIPA configuration appears in IPv4, that usually denotes a failure or a misconfiguration. That would be a failure of your DHCP service or a misconfiguration that caused two hosts to have the same IPv4 address, in which case the second host to join the network will assign itself a PIPA address. Now that concludes this session on Introduction to IPv4 Part 2. We talked about the difference between public and private IP addresses, and then we talked about automatic private Internet Protocol addressing. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on the Introduction to IPv6. Today I will be introducing you to IPv6, and I will be talking about some differences between IPv6 and IPv4. Now there's a whole lot of ground to cover, so let's go ahead and dive in. And I'll begin by introducing you to IPv6. So what is IPv6? Well, it is the answer to the question of what do we do about running out of IPv4 addresses. Unlike IPv4, IPv6 will provide enough IP addresses for the foreseeable future. Shortly after IPv4's creation and implementation, the Internet Assigned Numbers Authority, the IANA, which is the organization that is tasked with assigning routable IP addresses, realized that the available IPv4 address space would not be enough in short order. The IANA then set about creating its replacement, and they initially started working on IPv5. Well, while working on IPv5, they realized that it wasn't going to be large enough either. It wasn't going to be sufficient for the task, so they scrapped IPv5 and began working on IPv6. The IANA is confident that IPv6 will function as the replacement for IPv4 for many decades to come. Now, IPv6 works at layer 3 of the OSI model. Layer 3 of the OSI model is also known as the network layer, and its major focus is logical network and host addressing. IPv6's job is to provide logical network and host addresses to devices. IPv6 is a 128-bit binary addressing scheme. The 128 bits are grouped together in sets, with each set being separated by a colon. So it's a colon-separated number. Each set is 2 bytes long. For human readability, the binary IPv6 number is converted to a hexadecimal number, that's base 16, with each hexadecimal number being equal to 4 bits, which can be referred to as a nibble because it is half of a byte. An IPv6 address is 8 sets of 4 hexadecimal numbers, with each set being separated by colons. IPv6 provides for over 340 undecillion addresses. And what do I mean by that? Well, the address space is 2 to the 128th power, which is roughly equal to 340 times 10 to the 36th power. So that's 340 followed by 36 zeros. There's the specific number there below. I'm not even going to begin to try and read that. Now let's talk about IPv6's address structure. Every device receives 2 addresses, a locally significant address and a globally unique address. Let's talk about IPv6's local address structure. The first 64 bits of the local address represent the local network, and the last 64 bits represent the host. The local address structure follows the Extended Unique Identifier, the EUI format, specifically the EUI 64. The 48-bit MAC address is padded with 16 bits to make it 64 bits in length. There is a specific formula for doing that. You just need to know that it's done. Now, IPv6's global address structure is similar to the local structure. The host address is always the last 64 bits and follows the EUI 64 number. The network portion is actually composed of the routing prefix and the subnet for the network. It follows the CIDR convention, the classless interdomain routing convention, with the number following the slash denoting the routing prefix. The subnet is composed of the bits between the prefix and the EUI 64 host address. Now, there are some notation conventions that you need to be aware of with IPv6. The 128-bit nature of IPv6 makes it cumbersome to write out and can take up unnecessary space. Because of this, some rules were developed to ease the burden of writing out IPv6 addresses. The first rule is that any leading zeros in a set can be dropped. And the second rule is any single set or multiple continuous sets of consecutive zeros may be replaced by a double colon. So let's look at an example. This is the number that begins with the 2001 colon. We can then drop all the leading zeros. And there you see it's a little bit shorter. But we have 3 consecutive groups of zeros right there in the middle. Those can be replaced by the double colon. Now, you can only use the double colon once. Remember, there are 128 bits to this address, and the only way IPv6 will know how many zeros fill out that double colon is if you only use it once. These notation conventions make IPv6 easier to write out, but it's still difficult for us mere mortals to remember. But it does make it easier to write out. Now let's move on to some differences between IPv6 and IPv4. So now, while IPv6 is the more robust and versatile addressing scheme, IPv4 is not going anywhere soon. With its 340 undecillion possible addresses, IPv6 will allow for every device to have multiple unique addresses, and it will be the networking scheme of the future. IPv6 is actually easier to configure than its older sibling IPv4, especially since it can auto-configure its own addresses without the use of DHCP. However, its adoption has been hampered by the widespread popularity of IPv4. IPv4 is well understood and well entrenched. So IPv4 still remains in place, and network administrators will have to learn how to work with both of them. Now, both IPv6 and IPv4 can use Dynamic Host Configuration Protocol, but IPv6 is easier to manage without it. IPv6 allows devices to auto-configure their own network and host addresses through a discovery process. DHCP v6 is only used when a very specific network configuration is required. Well, both IPv4 and IPv6 have loopback addresses. That's a specific address that is used to determine if the TCP/IP protocol stack has been properly initialized. The loopback address that they use are different. IPv4 uses 127.0.0.1, while IPv6 uses ::1. Whole lot easier there. IPv4 devices or interfaces receive a single address, while each IPv6 device or interface receives at least two: a locally unique address and a globally unique address, making it more versatile. IPv4 has three clearly defined private IP address spaces, while IPv6 does not. Okay, it actually does have a private IP address space, but it's not really relevant because of the unique local addresses that are created. IPv4 is 32 bits in length and can provide over 4 billion unique addresses, while IPv6 is 128 bits in length and can provide over 340 undecillion unique addresses. In the long run, IPv6 will win out and overcome IPv4. Now that concludes this session on the introduction to IPv6. I began by introducing you to IPv6, and then I talked about some of the differences between IPv6 and IPv4. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Peripheral, and welcome to PACE IT session on the introduction to the transport layer. Today we're going to be introducing the transport layer, and then I'm going to do an introduction to TCP and then an introduction to UDP. And with that, let's go ahead and begin this session. I'll begin by introducing the transport layer. Now, most network models follow the OSI, the Open System Interconnect model of networking. It's composed of 7 different layers. Layer 7 is the application layer, Layer 6 is presentation, Layer 5 is session, Layer 4 is transport, 3 is network, 2 is data link, and Layer 1 is the physical layer. The layers all work together to create a system of communication that allows for different types of computing systems or networks to communicate with each other reliably. Now, Layer 4, or the transport layer, receives data from the session layer, Layer 5, and it determines what method or type of delivery is required for that data. The transport layer then hands the data with instructions for the method of delivery to Layer 3, the network layer, which is then responsible for determining where the data is going. Now, there are 2 main protocols used in the transport layer. Those protocols are TCP and UDP. With that, let's jump into the introduction to TCP. So TCP stands for Transmission Control Protocol. Now, it's a protocol that determines the type of delivery method that will be used in network communication. TCP uses a reliable method of delivery. And by that, TCP helps to set up the connection session, it establishes error control, and then it helps to tear down the network session once the communication is completed. Now, part of TCP's reliable delivery method is its 3-way handshake. The first part of the handshake is a request for a connection. It then receives the response from the other end. That's the second part. The third part is when TCP sends an acknowledgement back that also sets the sequence number that will be used in this stream of communication. Now, every packet that gets sent must be acknowledged by the receiver. If the sender doesn't receive the acknowledgement of a packet, the sender will then resend the packet. All packets are sent and received in order. Now, this does cause some network overhead, but TCP doesn't care about the overhead. Now let's move on to the introduction of UDP. UDP stands for User Datagram Protocol, and it's a protocol that determines the type of delivery method that will be used in network communication, just like TCP. In contrast to TCP, UDP uses an unreliable method of delivery. It doesn't help to set up the connection session, it doesn't establish error control, and it doesn't help to tear down the network session. Now, UDP could better be described as a best effort delivery method. It sends the data stream to the destination, trusting that the destination is A, listening for the data stream, and B, willing to accept that data stream. The data stream flows with no acknowledgement of it being received. UDP doesn't care if the other end of the stream actually receives the data. It's going to send it anyways. Now, not all network traffic can be treated the same. That is why there are both reliable and unreliable delivery methods. With TCP, the sender can be assured that the other end of the line has received all of the packets that were sent and that the packets were received in the proper order. This works really well for communication that is not sensitive to latency issues that are associated with the overhead of reliable delivery. UDP, on the other hand, strips off the overhead but sacrifices reliability. It is suited for network communication in which speed is more important than reliability. When using voice over IP, VoIP, it is more important for the flow of packets to be continuous than to be held up while waiting for packets to arrive in the right order or waiting for an acknowledgement. VoIP communication can survive the occasional drop packet. Now that concludes this session on the introduction to the transport layer. I did an introduction to the transport layer. I then introduced you to TCP and then to UDP. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on common ports and protocols. Today I'm going to do an introduction to ports and protocols, and then we're going to talk about some common ports and protocols. There's a whole lot of information to cover, so let's go ahead and begin this session. And of course, I'm going to begin with an introduction to ports and protocols. So let's start with ports. Now, ports are a method of specifying what protocol or service to access. Protocols and services usually use default ports so that they are easy to locate. Now, there are 65,536 individual ports that are available to be used for communication, kind of. Port 0 is reserved, so in actuality, only ports 1 through 6,535 are available. Now, the first 1,024 ports are specifically assigned to protocols and services, and these are called well-known ports. If you would like to take a look at the list of well-known ports, you can go to www.iana.org/assignments/port-numbers. They have a listing of all of the well-known ports. Now, ports can also be thought of as kind of like a phone number extension. The IP address is the main number you are trying to reach. The port number is the extension that you want to access at that main phone number. Now let's talk about protocols. Extending the telephone analogy, protocols can be thought of as the language that the two applications on either side of the connection agree to speak once the connection is made. Press 1 to continue in English. That would be like the protocol. Protocols translate requests into services. Most protocols use default ports, but some protocols must be user configured for the port that they use. So something to keep in mind, ports are not protocols and protocols are not ports. Even though the two are closely associated, they are not the same. Ports are used to request services or applications. Protocols are the service or application that is being requested. When a requester seeks to connect to a specific port, the requester is dynamically assigned its own port number, and it listens to that dynamically assigned port for the response. This also allows for computers to have many concurrent connections. Now let's move on to some common ports and protocols. Before I dive into this, you will see that some ports are bold. These are the ports that you need to know. You need to know all of the protocols, but you only need to know some specific ports. Now there's a whole lot of information here, and if you need to pause, feel free. I won't be offended at all. So let's start at the top with FTP, File Transfer Protocol. Now that's a standard protocol for transferring files between computer systems. It's assigned to port 20 and to port 21. Nowadays it mostly just uses port 20. Then we have SFTP, Secure File Transfer Protocol, and it's an encrypted version of FTP which uses Secure Shell for its encryption. It's assigned to port 22. Then we have SMTP, Simple Mail Transfer Protocol. This is the protocol that's used to transfer email from a client to an email server. It is also used to transfer email between email servers. By default, it's assigned to port 25. Then we have POP3, Post Office Protocol version 3. This is the protocol that's used by clients to retrieve their email from email servers, and it's assigned to port 110. Then we have IMAP, Internet Message Access Protocol. It is also a protocol used by clients to access email on email servers, but it allows the client to organize email on the server into folders, and it leaves a copy on the email server. It's assigned to port 143. Then we have HTTP, Hypertext Transfer Protocol, the one that everybody should be familiar with. This is the primary protocol used to transfer data over the internet and to request web pages. It's assigned to port 80. Then there's HTTPS, Hypertext Transfer Protocol Secure. It's the primary protocol that's used to securely transfer data over the internet using SSL or TLS, so Secure Socket Layer or Transfer Layer Security technology. In actuality, SSL should no longer be used. You should only be using TLS. By default, HTTPS is assigned to port 443. Then we have DNS, Domain Name System. This is the protocol that is used to map computer names to their IP addresses, as in www.google.com to IP address 74.125.28.104. Google.com is a whole lot easier to remember than that IP address. DNS is assigned to port 53. Then we have RDP, Remote Desktop Protocol. It's used in Microsoft networks by the Remote Desktop Connection and Remote Assistance applications. They use RDP to make remote connections. It's assigned to port 3389. Next up is DHCP, Dynamic Host Configuration Protocol. This protocol is used within networks to automatically configure computers with the correct IP configuration, as in their correct IP address, subnet mask, default gateway, and DNS server location. This uses 2 ports. The DHCP server is assigned to port 67. The requesting client listens for the DHCP server's response on port 68. Let's move on to LDAP, Lightweight Directory Access Protocol. This protocol is used for accessing and maintaining distributed directory information services, as in Active Directory domain services. It's assigned to port 389. Then we have SNMP, Simple Network Management Protocol. This is a protocol that's used to monitor and manage local area networks. Next up is SMB, Server Message Block. This is a protocol that's used to transfer files over a network, kind of like FTP, but the process is transparent to the user. The user really never sees SMB. It's assigned to port 445. Then we have CIFS, CIFS, Common Internet File System. This is a protocol that's used to share files across intranets, internal private networks, and the internet. It's assigned to port 3020, and it has a lot in common with SMB. I mentioned Secure Shell earlier, SSH. Well, it's a protocol that's used to encrypt data traffic on a network. SSH is assigned to port 22. And finally, we have Telnet. This is a protocol that's used for remote access to systems. It is unsecure, but it is a bidirectional terminal service, and it does come in handy on occasion. It's assigned to port 23. That was a whole lot of ports and protocols. If you need to, feel free to go back through it. Do it as many times as necessary until you have these ports and protocols down. Now that concludes this session on common ports and protocols. I did an introduction to ports and protocols, and then I went over briefly some common ports and protocols. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. And welcome to PACE IT's Introduction to Wireless Networking. Today we're going to be talking about wireless network standards, and then we're going to move on to encryption for wireless networking. There's a whole bunch of technical information to cover, so let's go ahead and begin. And we're going to begin by talking about some wireless network standards. Now, wireless networking standards are established by the 802.11 Committee of the Institute of Electrical and Electronic Engineers, the IEEE. Quite often, we use the term Wi-Fi to describe an 802.11 network. Now, this is technically incorrect. Wi-Fi is actually a reference to the Wi-Fi Alliance. The Wi-Fi Alliance is the organization that's responsible for certifying that wireless networking equipment actually meets the 802.11 standards. Wi-Fi has become synonymous with the wireless local area network in the English language. So if you hear Wi-Fi, no big deal. Just remember that it is a reference to the Wi-Fi Alliance, not necessarily to the 802.11 standard. So let's talk about the 802.11 base standards. First off, it describes a method of half-duplex networking by using a portion of the radio frequency spectrum, the RF spectrum. Half-duplex describes a method of network communication in which a device can send or receive information, but it cannot do both at the same time. If it could, that would be full-duplex networking, and that wouldn't work in this situation. The most common RF bands used are the 2.4 gigahertz ISM band and the 5 gigahertz UNII band. So why do we use these two specific bands? Well, that's because in the United States they can be utilized without a license from the FCC. If you try and use any other bands, you need to get a license from the FCC, and that gets a little bit cumbersome. So now let's move into more detail on the 802.11 standards. If you need to pause, that's okay. I'll understand. First up is 802.11b. It was introduced in 1999, and it utilizes the 2.4 gigahertz band. It offers up to 11 megabits per second networking with a maximum indoor range of 115 feet and a maximum outdoor range of 460 feet. Then there was 802.11a, and it was also introduced in 1999, but it actually was introduced after 11b. Now it utilizes the 5 gigahertz band and offers up to 54 megabits per second of networking with a maximum indoor range of 115 feet and a maximum outdoor range of 390 feet. Then there was 802.11g. It was introduced in 2003. It utilizes the 2.4 gigahertz band and offers up to 54 megabits per second networking with a maximum indoor range of 125 feet and a maximum outdoor range of 460 feet. As wireless became more popular, we needed to come up with some techniques to increase the speed. So along came 802.11n. It was introduced in 2009, and it can utilize both the 2.4 and the 5 gigahertz bands. It does this by using multiple input and multiple output technology, MIMO technology. With MIMO, we use multiple antennas and multiple radio transmitters to increase throughput. Now, it offers up to 600 megabits per second networking with a maximum indoor range of 230 feet and a maximum outdoor range of 820 feet. Well, 600 megabits per second was not enough, so along comes 802.11ac. Now, this was approved in January 2014, and it only utilizes the 5 gigahertz band. It is expected to offer up to 1 gigabit per second networking with a maximum indoor range of 115 feet, and they haven't set the maximum outdoor range yet. There are some other standards that are coming along, they just haven't been approved yet. Now let's move on to encryption for wireless networking. Why do we need encryption for our wireless networks? Well, because they transmit over the air. Anybody can intercept the signal. So for security, we should encrypt our wireless networks. So that brings us to the encryption standards for the 802.11 network. First up is WEP, Wired Equivalent Privacy. Now, it was introduced in 1999. It works by using a key and the RC4 algorithm. Now, the key and the RC4 algorithm encrypt the signal. WEP was fully broken in 2001, and if you're going to secure your network, it should not be used. WEP was replaced by WPA, Wi-Fi Protected Access. Now, this was introduced in 2003 as a stopgap measure. It was never intended to have a long life. But WPA was designed to be backwards compatible with equipment that could use WEP. It used the same RC4 algorithm as WEP, but it also introduced TKIP, Temporal Key Integrity Protocol, in an effort to increase security. And as I said, it was backwards compatible, so it could be used by pre-2003 access points. TKIP ensures that each packet has a unique encryption key, but WPA is still easily broken and should not be used in a network. Its replacement was WPA2, Wi-Fi Protected Access 2, which was introduced in 2004. It's much more robust than earlier standards, and it introduced AES, Advanced Encryption Standard, into the process. AES is a symmetrical encryption standard, which means that both ends of the channel use the same key to decode the transmission. AES is very hard to break. AES is the current standard and has been accepted worldwide as an encryption standard. Now, because wireless network traffic is broadcast over an unlicensed band, wireless networks tend to be less secure than wired networks. Always make sure when you're setting up a wireless network that you use the proper encryption standards. Never leave your wireless network unsecured. Also, when you're using a public wireless network, be sure to use care and caution. You can never be positive just how secure it is. So I would recommend never sending sensitive information over a public wireless network. Now that concludes this session on the introduction to wireless networking. We talked about wireless networking standards, and then we moved on to encryption for wireless networks. Now, on behalf of PACE IT, thank you for watching this session, and I'll do another one soon. I'm Brian Farrell, and welcome to PACE IT session on setting up a basic small office, home office network. Today we're going to be talking about the equipment list and then configuring the network. So with that, let's go ahead and begin today's session. So we will begin by discussing your equipment list. Planning is the key to setting up any network, including the SOHO network. First, you need to know what you and/or the client is trying to accomplish. Know what type of infrastructure is already in place. Is the space already pre-wired for Ethernet? Many modern buildings and homes are coming pre-wired with Cat5e or higher grade network cable. Know how complex the network is going to have to be. Is this just for simple access to the internet, or will the network be hosting a web server? Your plan should always try to exceed the current need, and the design should try to incorporate future growth plans as well. With that, let's move on to your equipment list. The first thing that you need to consider is your wide area network connection, your WAN connection. How is the network going to access the outside world? Then you should consider what type of wired or wireless router you're going to use. How is the network going to connect to that WAN connection? You also need to consider switches and or wireless access points. So you have your WAN connection, you have your wired or wireless router going to the WAN. How are your devices going to connect to that wired or wireless router? That's where the switches and wireless access points come in. And then what type of devices need to connect to the network? Each device is going to need a method of connecting to that network. Some will need network interface cards for wired networks. Others are going to need wireless adapters for wireless networks. And finally, you need to consider your network cabling. You may be required to install new cabling or to get the appropriate patch cords. And with that, let's move on to configuring your SOHO network. You have two basic options for configuring the SOHO. First off, you have the plug-and-play type network. This uses the default configurations of the equipment, and you let the equipment determine the network. This works best for small networks that don't require a lot of complexity or security, like most home networks. You know, your grandma doesn't need a whole lot of complexity in order to surf the web for kitten videos. Then there's the custom configuration. This is where you do not use most of the default configurations of the equipment. Instead, you modify the configuration files to specify exactly what the network equipment and the network clients can do. This works best for networks that require more complexity and more security. So let's talk about some of those custom network configuration considerations. The first thing is, how will your clients receive their IP addresses? You could require that they are manually configured. Only allowing manually configured IP addresses creates more security, but it's harder to manage. Or you could use a service like DHCP, using dynamic host configuration protocol to automatically assign IP addresses from a configured pool. It's easier to manage, but it does create a possible weakness in your network. So maybe you'll use DHCP, but you want to control who connects to your network. You can do that using Media Access Control Filtering, or MAC filtering. MAC filtering only allows specified MAC addresses onto the network. It's an effective security measure, but it can be difficult to control. Is this network going to require a DMZ, a demilitarized zone? A demilitarized zone should be required if a server will be hosted on the network that needs to be accessed from outside of the network. Say you're hosting a web server or an email server. The DMZ is an area of the network in which outside connections are allowed in while still protecting the internal network. A DMZ will require a custom configuration of the firewall. In most implementations of a DMZ, 2 firewalls are used. So let's talk about firewall placement and configuration. Most small office, home office, WAN connection devices offer firewall services as well as connection to the internet, and these will be sufficient in most cases. But if a DMZ needs to be deployed, the best method is to introduce an additional router and firewall into the network, with the DMZ residing between the WAN equipment and the new router firewall combination. If a DMZ is deployed, port forwarding should also be used at the router firewall level. Port forwarding is used to direct requests for specific resources, like a request for a web page, to the computer that has that resource. So the request comes into the firewall and is routed to the appropriate place. Let's talk about network address translation, or NAT, for a moment. NAT is when the internal non-routable IP addresses are transformed into routable IP addresses at the router. Now, this is usually turned on by default at the router, but you as the administrator can configure NAT to your needs. Now let's move on to wireless network configuration considerations. The first thing that you need to consider is the name of the wireless network. The name is called the Service Set Identifier, the SSID. Once you determine the name, then you need to determine your broadcast style. Is your SSID going to be broadcast in the clear, or you can set your SSID broadcasts to be hidden. But be aware, even if they are hidden, it is still being broadcast, which means that it can still be seen. It just takes a little bit more effort. And encryption needs to be turned on. By default, wireless routers and access points do not have encryption enabled. That makes them easier to set up, but unsecure. And at the minimum, WPA2 personal should be enabled. Now, some wireless networking equipment is coming with Wi-Fi protected setup, WPS, and it's enabled by default when it comes with it. Now, this allows for the auto configuration of wireless equipment in a secure wireless network. Sounds great, but this should be turned off and not used, as it creates a weakness in the wireless network. It's easily hacked. And because WPS can be easily exploited by an attacker, don't use it. Now, while there's a lot to consider in the custom configuration of a SOHO network, the effort will ensure a higher level of security and more control. With some planning and practice, the perceived complexity and difficulty in the configuration of a network is greatly reduced. The custom configuration of a network allows for a very high degree of control over how the network behaves and how secure it is. Now that concludes this session on setting up a basic SOHO network. We talked about your equipment list, and then we moved on to configuring the network. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on alternative internet connections. Today we're going to be talking about cellular internet connections, WiMAX internet connections, and then we will conclude with satellite internet connections. We have a fair amount of information to cover, so let's go ahead and begin this session. And of course, we're going to begin by talking about cellular internet connections. So let's start by talking about the evolution of cellular networking. Now, cellular communication has been around for a while, and it started off with what is now called 1G cellular, and it was only capable of voice transmission. The first type of data communication beyond voice occurred with the implementation of second-generation cellular, and that added simple data transmission capability, specifically text. We didn't have a true connection to the internet until the implementation of 3G, or third-generation cellular. And it was pretty basic. It wasn't exactly fast, but it wasn't exactly slow. It was just kind of there. One of the versions of 3G networking that you need to know about is HSPA+, which stands for Evolved High-Speed Packet Access. And it was a stopgap measure between 3G and 4G. It has download speeds of 3 to 4 megabits per second with an upload speed of 1 to 2 megabits per second, depending upon how far away you are from the cell tower. And then along comes 4G. Well, 4G is still an emerging technology. It currently consists of LTE and WiMAX. LTE stands for long-term evolution, and it uses an all IP-based core with high data rates, well, at least reasonably high. It is compatible with 3G, so it is backward compatible, and it is compatible with WiMAX. And LTE has download speeds of 7 to 12 megabits per second with upload speeds of 3 to 5 megabits per second, a whole lot faster than HSPA+, but still not as fast as a wired connection to the internet. Now, some of the things that you need to consider about cellular networking is, first off, cellular connections can be intercepted. They are susceptible to a man-in-the-middle attack. That's because you're transmitting and receiving from cell towers to your cell phone, and anybody with the proper equipment can intercept those packets. They may not be able to read them, but they can be intercepted. Also, using the cellular system for internet access usually involves having to purchase an additional data plan. Now, this adds an additional cost to owning a cell phone. Also, be aware that it can be easy to exceed data plan limits, therefore costing you even more money. Now let's move on to WiMAX internet connections. WiMAX actually stands for Worldwide Interoperability for Microwave Access. Now this is a technology that uses microwave transmissions for networking. The microwave stations must have a line of sight between them in order for the connections to be made. It is usually deployed at the metropolitan area network, the MAN level, not at the wide area network level, or at the local area network level, LAN. You won't really find WiMAX at the LAN or the WAN, but you will find it at the MAN level. It was initially developed as a last mile alternative for situations where DSL or cable were not available. It offers download speeds of 5 to 6 megabits per second with upload speeds of 2 to 3 megabits per second, so fairly comparable with LTE. Many municipalities are currently exploring the possibility of developing their WiMAX coverage to offer free or inexpensive internet connections for their citizens. Now, WiMAX is semi-compatible with cellular networking. It's often considered a type of 4G connection. As a matter of fact, it's usually classified with LTE. And WiMAX is compatible with LTE, however, it is not compatible with second generation or 3G cellular networking. Now let's move on to satellite internet connections. Now, satellite internet connections use microwave transmissions for an over-the-air method to transmit voice and data. This can be an effective means of extending network coverage into hard-to-reach places where other methods of connecting to the internet are not cost-effective. It uses microwave radio relays as its method of transmitting voice and data through the atmosphere. Just like with WiMAX, the relay stations must have a line of sight between them. Now, satellite internet connections use communication satellites to form part of the microwave relay network. The satellites are placed in known geostationary orbits. That means they orbit over the same place all the time. And the terrestrial microwave dishes are pointed at the satellites. This satisfies the line of sight requirements for microwave transmissions. Now, satellite connections can be affected by poor weather conditions, particularly when there's high moisture content in the air. So during heavy rainstorms or snowstorms, your satellite service may be interrupted. Satellite connections also tend to suffer from high latency issues. That means that there's a lag. The signal needs to travel from the terrestrial satellite dish up to the satellite, which is typically over 22,000 miles above the Earth, and then back down to its destination. For you to receive the response, then you have it coming back in the reverse order, and that's why there tends to be a latency issue. But if your only option is satellite or nothing, guess what? Satellite works awesome. Now that concludes this session on alternative internet connections. We talked about cellular internet connections, then we moved on to WiMAX internet connections, and we concluded with a brief discussion on satellite internet connections. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on types of internet connections. Today we're going to be talking about dial-up internet connections, then we'll move on to DSL internet connections, and then we'll conclude with other types of internet connections. And with that, let's go ahead and begin today's session. Of course, we're going to begin by talking about dial-up internet connections. Now, dial-up utilizes plain old telephone service, POTS service, through the public switched telephone network, the PSTN. Now, dial-up requires the use of a modem to transmit data as an analog signal over the twisted pair plain old telephone service lines. Your max theoretical speed in the United States using dial-up is 56 kilobits per second. Now, back in the day, 56 kilobits was pretty fast, but man, is that slow now. Now, a type of dial-up service, but different, is the Integrated Service Digital Network, the ISDN line. This is a digital point-to-point dial-up wide area network technology that utilizes the public switched telephone network. You can achieve up to approximately 2 megabits per second networking on a primary rate interface, a PRI interface. Now, a primary rate interface uses what are called B channels. As a matter of fact, it uses 23 of them, and it uses one D channel. They're kind of bundled together, and that's how you get up to 2 megabits per second networking. Most often, a primary rate interface is not what companies use. They will use what's called a basic rate interface, a BRI. Now, these are deployed at multiples of 128 kilobits per second. Now, a BRI uses 2 B channels at 64 kilobits per second each, one for data and one for voice, and one D channel which operates at 16 kilobits per second, which is used for call setup and link management. Now, you can bundle basic rate interfaces together to achieve more speed. An ISDN connection requires the use of a terminal adapter, or TA, for the connection to the end node. It looks like a modem, but it's not a modem. Now, ISDN connections are more expensive than dial-up and not as capable as digital service line, but they can be used when DSL is not available. And with that, let's move on to DSL internet connections. Now, DSL stands for Digital Subscriber Line. It's a digital internet connection using the plain old telephone service as the transmission media. It creates a dedicated digital line between the endpoint and the network supplied by the internet service provider, the ISP. It's an always-on type of internet connection. DSL carries voice and data. Now, filters are put in place so that you can get a clear voice channel, but DSL does carry both. Now, the speed of the DSL connection varies depending upon the ISP and the type of DSL service that you're paying for. As a rule, the ISPs do charge for the amount of bandwidth that they provide to the premise. Now, there are two main flavors of DSL, and we're going to start by talking about ADSL, asynchronous DSL. With ADSL, download speeds are faster than upload speeds. It's usually more cost-effective for the small office, home office environment than SDSL. Now, SDSL stands for synchronous DSL. Download and upload speeds are the same. Often when SDSL is deployed, it's used in conjunction with a leased T1 line. Now, as a rule, SDSL costs more than ADSL. And in most SOHO cases, ADSL works just fine. Now let's move on to some other internet connections. Now, cable is a broadband connection to the location. It's delivered by the cable company using the cable company's own network. They typically offer more bandwidth for less cost than DSL. It's also an always-on connection to the internet. Now, the way it works, the cable signal is delivered to what's called the head end. This is where all cable signals are received, and the signals are processed and formatted and then transmitted to the distribution network. The distribution network is a smaller service area that's served by the cable internet service provider. The distribution network architecture can be composed of fiber optic cabling, coaxial cabling, and or a hybrid fiber coaxial cabling network, an HFC network. But the final distribution to the home or office is usually through a coaxial cable. Now, unlike DSL, the bandwidth that the cable ISP provides is shared by the distribution network. This can lead to increased latency and congestion during peak usage times as everybody is surfing the internet. Now let's move on to fiber optic internet connections. This is using light to transmit data and voice at a higher bandwidth. Fiber optic cables are used to make the connection to the ISP's network. The fiber optic cabling allows for higher bandwidth, which means that the end user is granted more and faster internet access. Quite often, fiber optic connections will not only carry internet, but they'll also carry telephone connections as well as telephone service, and they do so with ease. However, it does tend to be the most expensive option for connecting to the internet. Like DSL and cable, fiber optic connections are a type of always-on connection to the internet. Now that concludes this session on types of internet connections. We talked about dial-up internet connections, then we moved on to DSL internet connections, and we concluded with some other types of internet connections. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on types of networks. Today we're going to talk about categories of networks, and then we're going to move on to network topologies. Now there is a lot of information to cover, so let's go ahead and dive right in. And let's start by talking about categories of networks. So when you're describing a network, you have a couple of different options. Are you going to describe its function or its design? If you're going to describe the network's function, then the first place to start is with what category of network it is, and then build from there. If you're going to describe its design, then the first place to start is with its topology. But we're going to start with categories of networks. And the first category we're going to start with is the local area network, the LAN. Now, this is composed of a single network address range. That address range may be broken into subgroups called virtual local area networks, VLANs, but they're still all part of the same network address range. LANs can span from a small area, like a single room, to a building or a small group of buildings. LANs tend to have the highest speed on the network of any of the categories. 802.3, which is Ethernet, and 802.11, which is wireless, are the most common types of networks found on the LAN. Then there's the Metropolitan Area Network, the MAN. It's larger than a LAN. Most often it contains multiple local area networks. Quite often they're owned by municipalities, so they're owned by cities or large entities. When they are owned by a private entity, sometimes they're called Campus Area Networks, CAMs. Now you're not going to find that term very often, but you need to be aware that it's there. Now let's move on to wide area networks, the WAN. Now this is a network which spans significant geographic distances. Quite often a WAN can be described as a network of networks. The best example of a WAN is the internet. Also, as a general rule, if the infrastructure has a single owner, then it's not a WAN. Now let's move to the smallest category of network, the personal area network, the PAN. These are extremely distance and size limited. Most often it's a connection between only two devices. A common example of that is Bluetooth technology. Bluetooth uses a PAN to connect two devices together. They tend to provide low throughput of data and have low power output. Also, as the distance between devices increases, throughput decreases. So now that we've talked about the main categories of networks, let's move on to network topologies. The way in which the nodes of the network are arranged or interrelated is how the topology of a network is explained. the description of the topology of a network can focus on its physical layout, as in how the nodes are actually arranged or connected, or the description of the topology can focus on how the data flows across the network logically, as in how the nodes interrelate. It's not uncommon for the physical and logical topologies to be different. For the most part, we're going to focus on the physical topology. The first topology that we're going to talk about is the bus. This is where a network segment is composed of a single cable, with each node connecting to that cable. The network signal flows from end to end past each device. A single break in the line will bring down the whole network. An example of the bus topology is the 10-base-2 network. Hopefully you won't see that anymore, but that is an example of the bus topology. Next up is the ring topology. It's denoted by its circular physical topology. The network signal flows around the circle past each node. Now, the ring topology does have some fault tolerance. If a single break occurs in the line, the path of the data is actually redirected in the opposite direction, so it can still reach all of the nodes. Now, the ring tends to be a legacy local area network technology. It is rather difficult to find a ring topology in the workplace. But the ring topology is still commonly found in the metropolitan area network and the wide area network environment. When it's deployed in the MAN and the WAN environments, multiple rings are often installed at the same time. This is to improve fault tolerance. If one ring goes down, another one steps up and takes its place. Now let's move on to the star topology. All of the nodes connect to a central device. This physical topology can also be deployed logically as a bus topology if a hub rather than a switch is used as the central device. But if a switch is used, then the physical and logical topologies are the same. The loss of one connection only affects the nodes on that connection. Then there's the mesh topology. In a full mesh topology, every node has a connection to every other node. But there are also partial mesh topologies. This is where there are multiple connections between nodes, creating different paths through the networks, but not every node is connected to every other node. Now, due to its redundancy, the mesh topology is very robust. However, this redundancy also tends to make it more difficult to manage and maintain. Quite often you'll find a partial mesh topology is deployed in the enterprise environment. Now, the internet utilizes both partial and full mesh topologies, making it a hybrid topology. So let's talk about what a hybrid topology is. Now, it's when there are multiple topologies found in the same networking environment. Like I said earlier, by its very nature, the internet utilizes a hybrid topology. Also, it's not uncommon to find multiple topologies in the enterprise environment. For example, the workstations may utilize a star topology, while the workstation switches may have a partial mesh topology between them. And then there are the core switches, which are often called backbone switches. These carry huge amounts of data and will often utilize a full mesh topology to ensure redundant connections and to create fault tolerance. And all of these can be found in the same networking environment, thus creating a hybrid topology. Now that concludes this session on types of networks. We talked about categories of networks, and then we discussed network topologies. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Network Devices Part 1. Today we're going to talk about hubs, bridges, and switches, then we'll move on to modems, and we'll conclude with routers. And with that, let's go ahead and begin today's session. And I'll begin with hubs, bridges, and switches. Before we begin with the actual devices, let's talk about the OSI model first. The Open System Interconnect model was developed as a way to help disparate computing systems, or networks, communicate with each other. It is composed of 7 layers that work together in order for communication to occur. Now, network devices tend to fall within the first 3 of those layers. Layer 1, the physical layer, deals with how bits are converted to the appropriate signal and placed onto the network. Layer 2, the data link layer, is more concerned with making sure that the appropriate host is reached on the network. And finally, there's layer 3, the network layer. Now, this is all about making sure that the right network is reached. Now remember, network devices can usually be classified by where they fall in the OSI model. So now let's move on to hubs. The hub operates at layer 1 of the OSI model. It is only concerned with physically placing the signal onto the network. All devices that connect to the hub are in the same collision and broadcast domains. Now, collision domains are areas where network traffic can collide and cause problems on the network. Broadcast domains are network segments where broadcast traffic is heard by all devices on the networks. A hub functions as a concentrator or repeater in that it doesn't care where the signal comes from or where it is going. When a signal comes in, the hub propagates it out all of its ports. Because of this, a hub can only operate in half duplex. It can be sending data or receiving data, but it can't do both at the same time. All of the network bandwidth that the hub receives is shared by all of the devices connected to that hub. This sharing of the bandwidth effectively reduces the amount of bandwidth that is available to each device. As the size of the network increases, the performance of the network will be reduced. Now let's move on to the bridge. Now the bridge operates at layer 2, the data link layer of the OSI model. Bridges connect different local area network segments together by creating a bridge between them, and they break up collision domains. So each side of the connection is its own collision domain. Now, bridges can also bridge different types of network media and different types of network transmissions. As in, you can have a bridge that goes between Ethernet and token ring, and or you can have wireless to Ethernet or wireless to token ring, so on and so forth. Bridges can do that. Bridges also have a limited amount of ports. Now, a special type of bridge is the wireless access point. It also operates at layer 2 of the OSI model. It's a specific type of network bridge that bridges wireless network segments with wired network segments. Now, the wireless access point can only operate in half duplex mode, and it does so using a method called carrier sense multiple access with collision avoidance, CSMA-CA. With CSMA-CA, devices will listen to the line. If there is no traffic on the line, the device is free to transmit. If there is traffic on the line, the device waits a random period of time and then listens in on the line again. While wireless access points do not break up collision domains, collisions are avoided by the use of CSMA-CA. Now let's move on to the switch. It also operates at layer 2 of the OSI model. It's similar to a hub, but it's also much smarter than a hub. It utilizes an application-specific integrated circuit, an ASIC chip. This ASIC chip has specific programming that allows the switch to learn what devices are on the network and which ports they are connected to. Because the switch knows which devices are on the segment and where they are located, they can operate in full duplex. Full duplex is when a device can send and receive signals at the same time. With full duplex, all of the devices receive all of the possible network bandwidth all of the time. They do not share the bandwidth as in the case of a hub. Now, switches break up collision domains on each of their ports. So each port on a switch is its own collision domain, so there are no collisions in a switched network. But switches do not break up broadcast domains. All devices connected to a switch will receive network broadcasts. Now let's move on to modems. Now the modem operates at layer 1 of the OSI model. The term modem is actually short for modulator demodulator. It was originally developed to take the digital signal coming from a computer and convert it to an analog signal, modulating the signal, to be placed on the wire. In return, it would accept an analog signal coming from the wire and convert it, demodulating the signal, to a digital signal that the node can understand. Modems were originally developed to create connections between network segments via the public switch telephone network, the PSTN, using the plain old telephone system, POTS. Cable modems can be used to connect network segments to the internet by translating the network signal into a format that can be handled by the cable network. Now, a modem is not a router. It is a point-to-point technology, and it doesn't care where the networks are. And with that, let's move on to our discussion about routers. So the router operates at layer 3 of the OSI model, the network layer. It is responsible for connecting different networks together. It uses special programming to keep track of different networks and the best possible paths to reach those networks. It's not concerned with what hosts are connected to those networks. They only care about individual networks. The routers are found at the edge of the network. Only makes sense since you don't want them in the center of your network, since they're only concerned about finding networks. Like the bridge, they can connect different types of media together. As in, you can have an Ethernet signal coming in and have it transformed into a serial connection, or Ethernet to fiber optic, so on and so forth. Now, routers do break up collision domains. Routers also break up broadcast domains because network broadcasts are for a specific single network. They cannot pass through a router's interface. So when a router receives a network broadcast, it just drops the broadcast. You could think of it as ignoring the broadcast. Why does it do this? Well, because broadcast traffic is only significant for the local network, not for remote networks. Now that concludes this session on Network Devices Part 1. We talked about hubs, bridges, and switches, and then I moved on to modems, and I concluded with a brief discussion on routers. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Network Devices Part 2. Today we're going to talk about firewalls, then we'll move on to network attached storage, and then we will have a brief discussion on some other devices that you'll find on your network. And with that, let's go ahead and dive into this session. So let's begin our discussion by talking about firewalls. Now, the firewall can be built into a router or it can be its own device. The firewall functions at multiple layers of the Open System Interconnect model, the OSI model. Specifically, it operates at layers 2, 3, 4, and 7. It's used to prevent or mitigate security threats. Its main purpose is to block packets from entering or leaving the network, and it does so by using two main methods. The first method is stateless inspection. In this method, the firewall will examine each and every packet that crosses through it against a set of rules. Once the packet matches a rule, the rule is enforced and the specified action is taken. The other method is stateful inspection. The firewall will only examine the state of a connection between networks. Specifically, when a connection is made from an internal network to an external network, the firewall will not examine any packets returning from the external connection. As a general rule, external connections are not allowed to be initiated with the internal network. Now, the firewall is the first line of defense in protecting the internal network from outside threats. You can consider the firewall as the police force of the network. And with that, let's move on to network attached storage. Network attached storage is commonly referred to as NAS, N-A-S. It's one solution to the data storage needs of the modern world. It's a specifically designed pool of storage. Now, network attached storage is usually deployed as a network appliance. A network appliance is a device that is purchased and deployed with a pre-configured operating system and software package. It is designed to perform a specific function and to do that function very well. Network appliances limit the amount of configuration that the user is allowed to perform. Now, network attached storage offers several different storage solution benefits. It's often designed and deployed with performance in mind, with some form of RAID striping and multiple connections to the network, thus increasing the possible throughput. Network attached storage is also often designed with high availability in mind, with some form of RAID mirroring and redundant systems in case of equipment failure. Now, network attached storage is always designed and deployed with high storage capacity in mind. The size of the NAS is usually only limited by the budget of the purchaser. Now let's move on to some other types of devices. First up is the voice over IP phone, the VoIP phone. This uses the network and internet to provide phone service. Now, the VoIP phone offers more than just normal telephone functions. It can automatically log traffic. They are often programmed with time clock applications, and they also often come programmed with a simple browser. Now, VoIP can reduce the cost of operating a telephone system through reduced long distance costs and also reduced cost and ease of management of the telephone system. Then there's a special type of network device called an internet appliance. These are a category of purpose-built devices that are designed to connect to a network and offer simple communication. An example would be a device that measures the amount of material in a tank, and when it reaches a certain level, it will send a message to reorder the necessary supply. They are usually designed to simplify a process or a procedure. Now that concludes this session on Network Devices Part 2. We talked about firewalls, and then I talked about network attached storage, and then we concluded on some other devices that you'll find on the network. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on tools for working on networks. Today we're going to discuss some cable tools and then some other tools that you might want to have in your toolbox. And with that, let's go ahead and begin today's session. And of course, I'm going to begin by talking about cable tools. Now, every technician should put some thought into the tools that are in his or her toolbox. It's often said that you get what you pay for, and that is very true with tools. While a good technician can get away with buying the most inexpensive tools, spending a little bit more money on some of them for a better tool can ease the job and ultimately make the technician more efficient. There is a flip side to this. It is very easy to overspend on tools as well and never be in a position to utilize all of the features that the tool provides. You will save money in the long run by thoroughly researching the tools that you need and desire before making any purchase. And with that, let's move on to some specific cable tools. And we start with crimpers. Every technician needs a set of crimpers. These are used to place cable ends on the ends of cables. They can be designed to work with a single type of cable, like twisted pair, or with multiple types of cables. Some crimpers are able to place ends on twisted pair cable and on coax. Next is the punch-down tool. These are used to secure cable wires into punch-down blocks, and good ones will trim the ends of those wires at the same time. In many cases, punch-down blocks are used to terminate cable runs in a central location. Quite often, these blocks are on the back side of patch panels. Now, a good punch-down tool will actually save your wrists and your fingers from fatigue. Then there's the cable tester. These are used to test cables for common problems, as in misconfiguration of the pinouts. They can test for the cable standard that's used. Is it T568A or is it T568B? Cable testers will also notify you if there's a short or break in the cable. Some types of testers can also test for cable length and the quality of the cable. If there's a particular place where you can overspend on a tool and not utilize all the functions, it's in the cable tester. Most of us will never need a TDR, a time domain reflectometer, which is a type of cable tester. Now let's move on to the toner probe. The toner probe is a tool that is used to trace a wire or cable from end to end. It is also sometimes called a fox and hound. Toner probes come in two pieces, the injector and the probe. The injector introduces a signal into a cable and the probe will emit a tone when placed on or close to the cable. This allows a technician to trace a cable by placing the injector on one end and following the cable to its endpoint. This comes in handy when placing a bundle of cables into a punch-down block and you want to know which cable is which. Every inexpensive toner probe that I've ever used has been difficult to work with, if it would even work at all. So I would recommend stepping up and spending a little bit more money on your toner probe. So now let's move on to other tools that you may want to have in your toolbox. And we begin with the multimeter. Now this is used to test for electrical current. Most can test for AC and or DC current and will also display the amount of current that is present. They're used to troubleshoot power issues. They can also be used to test the integrity of cables by testing for continuity, whether or not there's a break in the cable. You can also use a multimeter to ensure that your power supplies are putting out the proper voltages in your network. Now let's talk about loopback plugs. These are used to test the operation of a network interface or network interface card. A network signal is sent out from the interface and looped back into the interface to actually test its operation. Using just the loopback address will only actually test the TCP/IP protocol stack to ensure that it is properly initialized. Using the loopback interface will not test the physical interface for functionality. Loopback plugs are fairly easy to make, so you can make your own and save some money there. Now that concludes this session on tools for working on networks. I talked about cable tools, and then I talked about some other tools that you might want to have in your toolbox. Now on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on laptop expansion options. Today we're going to be talking about expansion cards, then we'll move on to random access memory, and we'll conclude with flash memory. Now, there's a fair amount of ground to cover, so let's go ahead and begin this session. And we'll begin by talking about expansion cards for the laptop. The laptop's small form factor, and sometimes its method of manufacturing, can make it functionally more difficult to expand. If increasing the functionality of a laptop is the goal, in some cases a technician doesn't have the option of just opening the case and inserting new hardware. However, in many cases, the increased capabilities can be achieved through other means. That's where expansion cards can come into play. The first expansion cards developed for laptops were the PCM-CIA card. They were introduced by the Personal Computer Memory Card Industry Association in 1990. They were also known as the PC card and later as the card bus. Originally, it was developed as a means of expanding the storage capabilities of very small form factor devices, and then it was extended to work with laptops. After its initial development, additional capabilities were added to the standards. Now, the PCM-CIA card either uses a 16-bit or 32-bit data path, and it came in 3 types. The first card developed was the Type 1 card. It's 3.3 millimeters thick, and it only came with the 16-bit data path. It was commonly used as additional random access memory, or as flash memory, or as static random access memory. Then along came the Type 2 card. It was 5 millimeters thick, and it could come with either a 16 or 32-bit data path. It introduced input-output support to the card. Commonly, they were used as modems or network interface cards. The final type of PCM-CIA card was the Type 3 card. It was 10.5 millimeters thick, and it always came with a 32-bit data path. This is the card bus card. It is more robust and allows for a full-sized interface as opposed to the compact input-output interfaces that came with the Type 2 card. External hard drives were also developed as Type 3 card bus cards. As the PC card or card bus card aged, we discovered that it didn't work as well as we'd hoped. So the PCM-CIA developed the Express card and introduced it in 2003 as the replacement for the card bus. It has all the features and functionality of the earlier cards, but also offers additional performance. And what do I mean by that? Well, it can take advantage of internal connections to either the PCIe or USB bus. This allows for possible transfer rates of 280 megabits per second in USB 2 mode and up to 3.2 gigabits per second in either USB 3 mode or in PCIe 2 mode. Now, the PCM-CIA disbanded in 2009. That means that this standard is no longer being developed. However, the standard is being maintained by the USB Implementers Forum, the USB-IF. Now, Express cards came in 2 formats, the Express Card 34 and the Express Card 54. The Express Card 34 is 34 millimeters wide and 75 millimeters long with a 26-pin connector. The Express Card 54 is 54 millimeters wide and 75 millimeters long, and it also had a 26-pin connector, and it's easily recognizable because it's L-shaped. Now, the Express Card 54 slot could accept either of the Express Card formats. So if your laptop came with an Express Card 54 slot, you could use either card in that laptop. Now let's move on to random access memory. Laptops use the small outline dual inline memory module, the SODIMM. It was developed as the random access memory solution for the smaller form factor. In many cases, it is an easily performed expansion option used to increase the performance of a laptop. SODIMMs came in many different versions. There was the 100-pin SD-RAM, the 144-pin SD-RAM, the 200-pin DDR, the 200-pin DDR2, the 204-pin DDR3, and the 260-pin DDR4. Increasing the amount of SODIMM in a laptop can increase performance, just as increasing the amount of RAM in a PC does. In modern laptops, it's not uncommon for their SODIMM to be soldered in place. In these cases, you cannot easily upgrade the RAM. Now let's talk about flash memory. So what is flash memory? Well, it's a type of non-volatile computer memory that was developed by Toshiba. Non-volatile means that it doesn't require an electrical charge to maintain the state of the data. It's commonly used as a highly portable method of storing data and applications. Its most common form factor is the USB flash drive. It is reasonably inexpensive and it can operate at high speeds. Now, some operating systems can use flash memory as random access memory. Specifically, Microsoft developed ReadyBoost as a means of caching data on flash, effectively extending the random access memory to the flash memory module. That often leads to an increase in the performance of a laptop. Due to the nature of its construction and operation, flash memory performance does degrade over time, and it will eventually wear out. But don't worry, in most cases, you lose it before you wear it out. Now that concludes this session on laptop expansion options. We started with expansion card options for the laptop, then we moved on to random access memory, and we concluded with flash memory. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on common laptop components. Today we're going to be discussing components that are found inside the case, and then we'll discuss components that are found outside of the case. And with that, let's go ahead and begin this session. And we'll begin by talking about common components found inside the laptop's case. As laptops are designed to be portable, they are smaller and lighter than most desktop systems. This has led to some basic differences in the components of the laptop. Many of the components found in the laptop are proprietary to the manufacturer of that laptop. Also, while many laptops can be upgraded, it can be more difficult and expensive to perform those upgrades. So now let's move to the inside of the case, and we're going to start with the motherboard. Each motherboard is designed specifically for the laptop in which it fits. They are non-upgradable beyond BIOS upgrades. That means if you burn up the motherboard and you want to replace it, you have to replace it with the exact same motherboard. Also, there is no standard form factor for the laptop motherboard. Now let's talk about laptop CPUs. Because of the nature of the motherboard, the CPU is not really upgradable either. Some modern laptops actually come with the CPU soldered in place on the motherboard. Also, it is more common to have integrated graphics in the laptop CPU than it is on the desktop CPU. Laptop CPUs are designed to consume less power. This increases the amount of time that the laptop can run on a battery. It also reduces heat output, which means they don't require as powerful of fans as the desktop CPU. As a downside, most laptop CPUs cannot handle the same workloads as a desktop CPU. They're just not meant to handle that kind of workload. Now let's talk about hard disk drives. The laptop computer has a smaller form factor than is commonly found in the desktop. The standard size of a laptop hard drive is 2.5 inches versus the 3.5-inch disk drive that's found in the desktop. A 2.5-inch disk drive has a smaller overall capacity than a 3.5-inch hard drive. Currently, it's not uncommon for laptops to come with solid-state drives instead of the traditional spinning platter hard disk drive. That can increase performance, but it can also lead to a reduction in storage capacity and add more cost to the laptop. The type of random access memory that the laptop uses is also different from the desktop. Laptops use small outline dual inline memory modules, SODIMMs. Now, SODIMMs do come in all of the current standards of full-size random access memory. The RAM in a laptop may be easily upgradable, or it may be soldered in place and cannot be replaced. Most laptops also come with built-in wireless networking capability. In most cases, this is achieved by using a wireless card that uses either a mini PCI or mini PCIe interface on the motherboard. The antenna for the wireless is commonly located in the hinged cover next to the screen. Now let's move on to batteries. Surprise, all laptops come with batteries that supply DC current to the system. They are specifically designed for the laptop. Many are easily replaceable. They're easy to remove and can be updated with batteries that meet the manufacturer's specification. But some are not field replaceable. They're proprietary to the manufacturer and/or they're soldered in place. All laptops use a special power cord. The cord receives the AC wall current and converts it to the appropriate DC current required by the laptop's battery. And not only do they supply that DC current to the laptop battery, but they do so in the wattage requirements that the battery needs. The power cord delivers the DC current to a DC jack located on the outside of the laptop. Because of the constant plugging in and unplugging of the cord, it's not uncommon for the DC jack to become loose inside the laptop. Now on the positive side, it can usually be reattached, so not a big deal. Lithium-ion is currently the most common type of battery for the laptop. Now let's move on to common components outside the case. So they may not really be outside of the case, but they're not inside of the case either. And we're going to start with the screens. Laptops have built-in screens that are located in the hinged cover. I bet you're surprised at that. Commonly, it's an LCD or LED type screen. Less commonly, it could be an OLED or a plasma type screen. Laptops come with keyboards. In most cases, the laptop keyboard is smaller and more compact than the desktop keyboard. To make up for this and to add additional capabilities, most laptops have a special function key. The function key will change the results of a key depression on certain keys. The alternate function that is performed is often colored in blue on the key. Laptops also come with a touchpad or trackpad. These are located below the keyboard and above the palm rest. It is used to move the cursor and to perform other operations. They're designed to sense finger movement, and you may find that you need to adjust the sensitivity on the touchpad to suit your needs. And that is usually adjusted by a software setting on the laptop. Some laptops come with a pointing device that is specifically designed to move the cursor. Usually it looks like an eraser head, and you'll find it embedded in the keyboard. Laptops come with speakers that are integrated into the system, and they are non-upgradable. Now let's move on to optical drives. Many laptops come with modular optical drives built into them. In some cases, the optical drive bay may be a multi-function drive bay, allowing some optional components to be used in the bay in place of the optical drive. I had a laptop for a while where I could pop out the disk drive and I could insert a special battery to extend the battery life of my system. Now, as the size and weight of laptops decrease, it is becoming harder and harder to find a laptop with an optical drive. Now that concludes this session on common laptop components. We talked about components inside the case, and then we talked about components outside of the case. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on laptop construction and deconstruction. Today we're going to be talking about common laptop construction, and then I'll move on to some laptop field repair topics. And with that, let's go ahead and begin this discussion. And of course, I begin by talking about common laptop construction. So what do I mean by common laptop construction? Well, what materials are laptops commonly made of? And we begin with plastic. Plastic is used extensively in the construction of laptops. Why? Because it's inexpensive, it's lightweight, it's easy to work with, and it's fairly durable, at least up to a point. It's not uncommon to find a laptop where the whole outside material is made of plastic. Then we have aluminum. It's used in higher-end construction of laptops. Why? It's more expensive than plastic, but it's still lightweight. And it's durable and rugged. It's more durable and more rugged than plastic. Other metal alloys are used in high-end construction of laptops. One example would be a magnesium cover. These materials are the most expensive, but they are very lightweight. They tend to be not as durable as aluminum, but are more durable than plastic. And there you have the common laptop materials. Now, laptops have fewer components that are easily replaceable in the field. For those components that can be easily replaced in the field, manufacturers commonly place access to them on the bottom side of the laptops. It's not uncommon to find access doors for the RAM or optical drives on the underside of the laptop. Just be aware that not all of them put these access doors in place, so you might actually have to remove the whole bottom of the laptop in order to get access to those components. Now let's move on to laptop field repair. Now, there is no standard method of breaking a laptop down to its individual components. Researching the manufacturer's documentation and other sources will be the key to successfully breaking it down and reassembling a laptop. The internet will be a vital resource when having to dismantle a laptop and perform any type of field repair. So now let's move on to some general tips for disassembling a laptop. First off, research the manufacturer's documentation on the process on breaking their laptop down. You can also research other sources on the internet. You can often find YouTube videos on the internet that'll show you exactly what you need to do to perform the repair you have in mind. Next, you need to develop a step-by-step plan. Make sure that you know the steps before you get into it. Then you should unplug the power cord and turn the system off. You don't want to be disassembling a live system. Document all screw and cable locations. A good idea is to take pictures with your cell phone so you know exactly where everything was and where it needs to go back. Systematically organize the parts. Use the appropriate tools to get the job done. I don't recommend a hammer, but you should use plastic wedges when there is a need to pry open something. With plastic wedges, there is less of a danger of marring surfaces. And remember, when you're reassembling, reverse the order of disassembly. Be very systematic and be very thorough. There's nothing worse than putting a system back together thinking you're done, only to find out that you missed something in the process. Now that concludes this session on laptop construction and deconstruction. I talked about common laptop construction materials, and we talked about laptop field repair. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the laptop display. Today we're going to be talking about different display types, and then we're going to talk briefly about some other laptop display topics. And with that, let's go ahead and begin this session. And of course, we're going to start by talking about the display types. All laptops use some form of flat panel display, and most of them will get the job done in a reasonable manner. However, that doesn't mean that all laptop displays are equal. All of the available types have their own benefits. But as with all things, if there is an upside, there is also a downside. And it's up to the user to decide which type of display is the right one for them. Often it'll come down to money, or battery power, or just personal preference, but it's up to the user to decide which one will work for them. So now let's talk about the liquid crystal display, the LCD. Basically, it's composed of a liquid crystal solution that is placed between two sheets of polarizing material and a fluorescent backlight. An electrical current is used to change the orientation of the liquid crystals, which will then refract light differently, giving you different colors. On their own, liquid crystals do not emit any light. What the user actually sees is the refracted light from the fluorescent backlight. Now, LCDs are inexpensive, they're lightweight, and they use relatively low amounts of power. They're a pretty good option for laptops. On the downside, their color representation may not be as good as with some other types of display technology. Also, as the liquid crystals don't emit any light on their own, LCDs may not be the best solution for a bright environment. Then we have the light-emitting diode display, the LED display. Now, the only difference between an LED display and an LCD is that the LED display uses an LED backlight instead of a fluorescent backlight. They have the same pros and cons as the LCD. So let's talk about the plasma display. The screen is composed of millions of gas-filled cells. An electrical current is passed through those cells. It's used to cause the cells to fluoresce and emit a colored light. The benefits of a plasma display is that they have great color. They have a very fast response as well, and they work well in bright environments. On the downside, they're heavier than LCD or LED displays. They're also more expensive and consume more power, thus reducing the amount of time that a laptop can operate off of its battery. Then there are organic light-emitting diode displays, the OLED display. In this situation, the screen is composed of an organic compound film, which is luminescent when a current is applied to it. When a current is applied to the film, it lights up and presents the image on the display's surface. On the benefit side, they have great color, on par, if not better, than most plasma displays. They also offer very fast response. They're a quick display type. They work well for games. They also work well in bright environments because they emit their own light, and they have extremely low power consumption, allowing for much longer runtime on batteries. On the downside, OLEDs are much more expensive than other types of displays. Until manufacturers can get higher yields, don't expect to see OLED display prices come down anytime soon. Now let's move on to other laptop display topics. And we're going to begin by talking about the backlight. LCDs use a fluorescent backlight. The fluorescent backlight requires AC power from a DC system. So an inverter is used to convert the DC battery power to the AC voltages required by the backlight. LED displays, on the other hand, use an LED backlight. The LED backlight requires DC power from a DC system, thus eliminating the need for an inverter. Now, LCD and LED displays may develop backlight problems leading to a dark screen. The backlight itself may fail, or the inverter in an LCD may stop working. To troubleshoot whether it is the backlight or the display itself that's causing an issue, the best tool to use is a flashlight. If you shine a flashlight on a dark screen and you can see a faint image, then the issue is with the backlight. If you cannot see an image, then the problem lies with the actual display itself. In the modern laptop, it's not uncommon for there to be more in the laptop's cover than just the display. The cover is also the most popular place to put a webcam, with their associated wiring and circuitry. Also, if the laptop comes with wireless capabilities, either 802.11 or Bluetooth, it's the most likely place for the antenna placement. In these situations, the manufacturer will try and run the antennas and wires around the edges of the display. You need to be aware of that, so if you ever need to work on a laptop display, you need to realize there might be more in there than just the display. Now that concludes this session on the laptop display. We talked about display types, and then we moved on to some other laptop display topics. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on laptop features. Today I'm going to be talking about special function keys, then we're going to discuss the differences between a docking station and port replicator, and then we're going to conclude with a portability issue. And with that, let's go ahead and begin this session. And of course, we'll start with special function keys. So laptops are a type of mobile device that allows the user to take a significant amount of computing power to almost any place, anytime. While that is a tremendous boost to productivity, it does come with some trade-offs. The smaller form factor and portability mean that some concessions and adaptations must occur. Most often, the laptop doesn't have the same number of ports for connecting devices as the desktop. Additionally, monitors and keyboards tend to be smaller. On the plus side, many laptops have features built into them that are not present in most desktop computers. Laptop manufacturers have added some capabilities and options to laptops that are commonly accessed through the keyboard. These features are typically engaged through a special function key, an FN key on Windows machines or the command key on Apple products. Depressing the function key and then another key will access the desired action. Some of these include the ability to output your display to another monitor or a projector, to turn up or down the volume on the system, to adjust your screen brightness, which can either prolong your battery life or shorten it, turn on or off the keyboard backlight. By the way, those are very useful when working in a dimly lit environment. There also tends to be a function key or two that allows you to turn on or off your wireless capability, either Bluetooth or 802.11. The function keys that are present and their placement and their actual function is determined by the manufacturer of the system, so be sure and read the documentation that comes with the laptop. Now let's talk about docking stations and port replicators. Now, both of these devices serve the same basic purpose, that is to extend or expand the functionality and capabilities of the laptop. Because of the form factor, laptops often have less ports available for peripheral devices to connect to, and they tend to have a smaller display. Now that that's out of the way, let's talk about docking stations. Now, docking stations are about transforming the laptop experience into more of a desktop experience. They're designed and built for the specific laptop. The laptop is placed in the docking station, which offers a dedicated connection to external peripherals like a full-size monitor, full-size keyboard, and mouse. Plugging the laptop into the docking station automatically engages the desired peripherals. Many docking stations will also allow the laptop to connect automatically to a wired network. Port replicators are similar to docking stations, but a little bit different. They may be designed for the specific laptop, or they may be more generic or aftermarket in nature. The goal of the port replicator is to add additional ports to the laptop. A USB hub is a type of port replicator. Now let's move on to portability issues. So what am I talking about with a portability issue? Well, there is a problem. Because of their nature, laptops are very portable. Well, let's face it, that's the whole reason that we have them. But that also makes them very easy to steal. Now, there are a couple of solutions for this. Many laptop manufacturers have built lock slots into their laptops. A cable, kind of like a bicycle lock cable, is placed around a secure object, and then the special lock is inserted into the laptop's lock surface. Now, this will not stop the determined thief, but it will reduce the risk of loss. There are also add-on cable lock options. They work almost exactly the same as the built-in lock slot, but the connection point for the lock is usually epoxied onto the laptop's case. Now, cable locks may be a fine solution for some, but they also are a little bit of a pain. Most people don't use them. Another solution to the theft problem could be the implementation of a tracking service. Tracking services will not stop the loss of a laptop. However, they may help in the recovery of a stolen or lost laptop. Many tracking services offer more than just tracking. They may also offer the ability to remote lock the laptop or remote wipe the laptop. All depends upon the services offered and what you pay for. Now that concludes this session on laptop features. We talked about special function keys, then we talked about docking stations and port replicators, and I concluded on portability issues. Now on behalf of PACE IT, thank you for watching this program, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on thermal and impact printers. Today I'm going to discuss thermal printers, and then I will discuss impact printers. And with that, let's go ahead and begin this discussion. And of course, we'll begin by talking about thermal printers. The most common use for thermal printers is as receipt printers. Why? Because they're easy to set up and easy to use. They're also extremely low maintenance. How do thermal printers work? Well, a feeder assembly moves specially coated heat-sensitive paper past the printhead assembly. The printhead uses heat to cause a reaction on the paper, and that reaction is actually the printed words. As I'm sure you're well aware, this specialty paper is not very durable. Now, a cutter head is used to cut the receipt at the proper length. The speed of a thermal printer is usually measured in inches per second. They're not as fast as some types of printers, but they print receipts really well. Now, as far as maintenance is concerned, the first thing is to follow all safety precautions. The most common maintenance task that you're going to have to perform on thermal printers is replacing the paper and getting rid of paper dust. Using canned air, by the way, is a great way of removing that paper dust. Now let's move on to impact printers. So what's their common use? Well, they're commonly used in situations where multiple copies are required. Because of that, they're often used with multi-part paper, carbon type paper, only they don't use carbon anymore. Now, impact printers do not produce letter quality work, especially if a 9-pin head is used, but they can produce near letter quality work with a 24-pin head. How do they work? Well, the paper is attached to the sprockets of the tractor feed. The sprockets move the paper through the printing process. As the paper is moved past the print head, the pins in the head are fired as the head moves back and forth. The pins strike an ink-soaked ribbon which prints on the top copy, while the force of the pin strike marks the underlying copies if there are any present. Now let's talk about impact printer maintenance. First off, just as with thermal printers, follow all safety procedures. Impact printers tend to produce quite a bit of paper dust and debris. Use canned air to clean that out of the printer. The next most common maintenance task is the need to replace the ink ribbon, so you replace it as necessary. And finally, if your print head no longer fires all of its pins, you need to replace the complete print head in order to fix that. Now that concludes this session on thermal and impact printers. I talked about thermal printers, and then we briefly discussed impact printers. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on laser printers. Today I'm going to do an introduction to the laser printer, and then I'll discuss the laser printing process, and then we'll touch on laser printer maintenance. There's a fair amount of ground to cover, not a whole lot of time, so let's go ahead and jump into it. So I'll begin by introducing you to the laser printer. Laser printers produce high-quality print jobs through the use of a laser, electricity, toner, and heat. Now, unlike other types of printer, the actual printing to the page is done a whole page at a time. rather than a line at a time like other printers do. Laser printers can be relatively small and simple, or they can be large, high-capacity printers that are highly complex. They can duplex, they can collate, they can organize, or like I said earlier, they can just be a simple printer. Laser printers are faster than other types of printers. Part of that is the fact that they print a whole page at a time instead of line by line. Laser printers also have a higher initial cost to acquire. That means they're more expensive than other types of printers to buy. But in most cases, they also have a lower cost to operate on a per page basis than printers like inkjets. That means it actually costs you less per page to print, but you have to spend more up front to get. Color laser printers use the cyan, magenta, yellow, black color model that's used in printing rather than the RGB, the red, blue, green model that's used in display technology. So how does it work? Well, a negative electrical charge is evenly applied to a rotating photosensitive drum. A laser is then used to neutralize the electrical charge in specific areas of the drum. That is the actual page image. It's the neutralized area. Toner is attracted to the image area. The toner is then transferred to the paper. The toner and the paper are then sent to a fuser assembly where the toner is fused or melted to the paper and the printed page is produced. Now let's move on to the actual laser printing process. So the laser printing process has 7 steps. The first step is processing. This is also called the raster imaging process. A raster is a single line of dots that are used as a component of an image. A raster image is all of the lines of dots that make up the image of the page or on the page. A raster image processor, or RIP, is used to take input from the computer about the print job and create the raster image of the page. Now that that's over with, what you need to remember is that processing is the creation of the raster image of the page. The next step is charging. A primary charging roller applies an even high voltage negative charge to the photosensitive imaging drum. The common voltage ranges between a negative 500 and a negative 600 volts direct current, but it may be as high as a negative 1000 volts direct current. The charging process will actually remove any leftover charge from previous jobs, and it prepares the drum to receive the new image, which is the next step, exposing. A laser is used to expose the raster image to the drum. Where the laser hits the drum, the high voltage negative charge is neutralized, preparing the drum to receive the toner, which occurs in the developing step. The toner, which has a negative electrical charge, is attracted to the raster image area on the image drum. So it's attracted to the neutralized area of the image drum. Step 5 is the transferring process. During this process, pickup rollers roll over the paper while separator pads roll in the opposite direction to ensure that only one page is picked up at a time. While the transfer roller is rolling over the paper, it gives an electrical charge opposite to that of the toner to the paper. The paper then moves past the imaging drum and the toner is attracted to the paper. It actually kind of jumps to the paper. As soon as that happens, a static eliminator removes the electrical charge that was on the paper, and we're on to the fusing process. During the fusing process, the paper with the toner is passed through the fuser assembly, which uses heat to melt the toner into the paper, making it a very durable image. The last step in the process is the cleaning process. Excess toner is scraped off of the imaging drum and collected for disposal. An erase lamp is also used to neutralize any remaining charge on the imaging drum, preparing it to receive the next raster image. In some manuals, you may see the cleaning process being listed as the first process. first or last, it doesn't really matter as long as everything flows in order. Now let's move on to laser printer maintenance. First up in maintenance is safety. Always remember, safety first. Because laser printers deal with high voltages, care and caution when working on them is mandatory. It's not optional, it's mandatory. There is also a danger of being burned by the fuser assembly. Always review the operating manual and follow all safety precautions. Now let's move on to the maintenance tasks. First up, replace toner is required. It's going to be the most common task that you perform on a laser printer. Now something to remember, if toner is spilled, avoid contact with it. It's not very healthy for you to get it on your skin. And clean up the spill immediately. If you use a vacuum, make sure that it has a HEPA type filter. You don't want to push that toner into the air. Cleaning the inside of your laser printer is the next most common maintenance task. Remove paper dust and debris following the printer's service manual. Then there are maintenance kits. You need to apply maintenance kits at the recommended service intervals. Most of the time those service intervals are based on the number of pages that are printed. Most maintenance kits include new pickup and separator rollers, transfer rollers, and fuser assemblies. Applying the maintenance kits correctly will prolong the life of the printer and help to ensure that quality print jobs are produced. And finally, you need to calibrate the printer as needed. Most printers come with calibration software to ensure that the quality of the print jobs remains high. Now that concludes this session on the laser printer. I did an introduction to the laser printer, then we talked about the laser printing process, and we finished with laser printer maintenance. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on inkjet printers. Today we're going to be talking about inkjet printer parts, how inkjet printers work, and then we will conclude with inkjet printer maintenance. Now with that, let's go ahead and dive into today's session. So of course, we're going to begin by talking about inkjet printer parts. First up are the ink cartridges. Now these are designed to work with specific printers. They're the main consumable resource of any inkjet printer. Color inkjets use the CMYK, the cyan, magenta, yellow, black color process to produce the RGB, the red, blue, green color spectrum. There are two main types of print heads with inkjet printers. The first one is the fixed head printer. Now the fixed head is attached to the carriage. It is designed to last the lifetime of the printer. Then there are the disposable head. These are attached to the ink cartridges themselves. They are designed to be replaced when the ink cartridge is replaced. Then there is the carriage and belt assembly. This carries the print heads back and forth across the page as the page is being printed. Now let's talk about rollers and feeders. This is where one or more roller is designed to pick up paper from the paper tray and feed it through the printer at a constant rate. And finally, there's the duplex assembly, which allows for two-sided printing. It's an add-on attachment for some inkjet printers. The duplex assembly can be used when two-sided printing is desired. After the first side of the page is printed, the duplex assembly will actually turn the paper over and send it back through the printer. This allows for the back side of the page to be printed without user intervention. Now let's move on to how inkjet printers work. First off, inkjet printers are the most common printer in the small office, home office environment. Why? Because they're relatively inexpensive, they're easy to use, and they're easy to maintain. Inkjet printers can be capable of producing good to very high quality print jobs. Some are capable of producing fine streams of ink that achieve 1,440 by 720 dots per inch. Now there are two main types of inkjet printers. There's the piezoelectric type printer. Now this is where an electric charge is applied to a crystal in the printhead, causing the printhead to vibrate. This vibration causes ink to spray out in a fine stream. The piezoelectric printhead constantly has ink running through it, so it's always ready to receive that electrical charge and print. Then there are thermal inkjet or bubble jet printers. In this case, heat is used at the printhead to cause the ink to bubble or boil. When the bubbles burst, a fine spray of ink occurs and lands on the page. The thermal printhead only receives ink as needed for printing. So unlike the piezoelectric type printer, the printhead only has ink in it when it's ready to spray it out. Now let's talk about the printing process. The computer sends the print job to the printer as a raster image. A raster is a line of dots that are used to make up a portion of an image or a character on a page. A raster image is all of the lines of dots that make up an image or all of the characters on a page. The roller picks up a single page of paper and sends it through the printer. As the page passes by the carriage assembly, the ink is applied to the page. The belt attached to the carriage assembly moves the printhead side to side, allowing the image or characters to be formed by the ink line by line. If a duplex assembly is attached and two-sided printing is requested, it will turn the page over and send it back through the printer for the other side to be printed. Now let's move on to inkjet printer maintenance. As with any maintenance task, first up is safety. Always read the manufacturer's maintenance and safety guides before performing any maintenance. The most common maintenance job with any inkjet printer is replacing inkjet cartridges. This is the most common maintenance task. You need to replace the cartridges as required. Once you replace them, you need to run the supplied calibration software to ensure that quality print jobs are produced. The next most common maintenance task is paper debris removal. Now, paper dust and debris can easily clog a printer. In most cases, using compressed air can clean out the printer of this debris. Always use eye protection when blowing dust and debris out of the printer. And finally, there's printhead cleaning. Most inkjet printers come with software that contains a printhead cleaning process. Run the cleaning cycle as required. With fixed printhead type printers, it is possible to use isopropyl alcohol and cotton swabs to clean off dried ink from the nozzle to help improve the quality of print jobs. Now that concludes this session on inkjet printers. We talked about inkjet printer parts, we talked about how inkjet printers work, and we concluded with inkjet printer maintenance. Now on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT's session on printer installation. Today we're going to be talking about basic printer installation, and then we're going to be talking about printer sharing. Now with that, let's go ahead and jump into this presentation. And of course, we're going to start with basic printer installation. The first thing that you need to know about printer installation is read the manufacturer's instruction for installing the printer. Of key importance is the driver and when to install it on the PC. Printer drivers are software that allows the computer to talk with the printer. They are what determines how the printer will interact with the operating system and can be used to fine-tune the printing process. Drivers are developed specifically for the hardware and the operating system on which it will run. Using an incorrect driver may result in loss of printer functionality. Additionally, the functionality of the printer may also be diminished if the driver is not installed at the correct time. So what is required to install a printer? Well, a computer, a printer with the correct drivers, and a connection. So what are your connection options? We start with wired. In the old days, you could use parallel and serial connections, but these are now a legacy option and are getting harder and harder to find. You can use Ethernet. This is connecting the printer and the computer through a direct Ethernet cable or through the wired network. And then there's USB, which is the most common connection in the small office, home office environment for connecting a printer to a computer. You also have some wireless options. First up, there's infrared. This requires a line of sight connection between the device that wants to print and the printer. And this is also considered a legacy option. Some printers allow you to connect to them via Bluetooth. This creates a wireless personal area network between the devices and has a limited distance, but it works well for small devices to connect to the printer. The most common wireless option for connecting to the printer is 802.11. This is connecting to the printer via a wireless network connection. This is the most common type of wireless connection to the printer in the small office, home office environment. Now let's move on to printer sharing. And first off, we need to talk about the difference between print device sharing versus printer sharing. Print device sharing is when the printer is placed on the network as a shared resource that is available to all authorized users. Some printers come with built-in connections and print servers. This allows them to easily connect with the network and to handle most print jobs with ease. For some printers to be installed on the network, an additional dedicated print server must be used. The print server will handle all of the requests for the printer as a resource. Then there's printer sharing. This is when the printer is installed on a single computer and that computer shares the printer as a resource that others may use. In this situation, not only does the printer need to be turned on, but the hosting PC must be turned on as well. Now, each operating system uses its own process for sharing printers as a resource. This is a good option for the small office, home office when it's not feasible to place the printer on the network by itself. However, it may require that additional drivers be added to the computer to accommodate other operating systems. Now let me show you an example of printer sharing. So let's share a printer, but before I begin, let me tell you that this is a Windows 7 operating system. It will be slightly different if you're using XP, Vista, or Windows 8, but it's close enough to get the job done. The first thing that we do is we click on the Start button, and we move to Devices and Printers. Then we click on that, and here are the list of devices and printers under this utility. We're going to share this Brother MFC printer. So I right-click on it, and I come down to Printer Properties. That'll open up this box, and then we go to the Sharing tab, and we click the Share This Printer. If you want to change the name of the printer, here's the box where you change it. We're going to leave it as the default. Here's a disclaimer on drivers. If this printer is going to be shared with different operating systems, this is letting me know that I might want to add additional drivers. But I don't want to. All of my machines are going to be Windows 7 or compatible. So we will just move on. The last thing that we do is we click OK. And there we go. That printer is now shared via my laptop. Now that concludes this session on printer installation. We talked about basic printer installation and printer sharing. Now on behalf of PACE IT, thank you for watching this session, and I look forward to doing some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to Safety Procedures. Today we're going to be talking about some governmental regulations, then we'll move on to personal safety, and then we'll conclude with component safety. And with that, let's go ahead and begin this session. And we'll begin by talking about governmental regulations. First off, compliance with governmental regulations are not an option. It's mandatory. Not everyone is willing to do the right thing when it comes to safety, whether it is for their own safety or the safety of others or even the safety of the environment. Because of this, a lot of governments pass regulations, and many of them have to do with the safety of workers and the environment. It is up to you to know and follow these regulations. Failure to comply can lead not only to your own injury or the injury of others, or it may involve fines. And in some cases, it could even result in prosecution. And nobody wants to go down that road. Now let's move on to personal safety. First up under personal safety, disconnect the power before repairing electronics. This reduces the risk of shock or electrocution. Remember that some devices contain capacitors that will retain an electrical charge even when disconnected from the power source. So know which components have capacitors. You should restrain or remove possible hazardous items. Jewelry should be removed before working on computers. Long hair should be restrained. Loose clothing should also be restrained. Remember to use proper lifting techniques. Bend at the knees, not the waist. Keep your head up. Avoid twisting when carrying items. If an item is heavy or awkward, request help in lifting it. And by the way, most companies establish weight limitations. That is, how much they will allow you to lift on your own. Please abide by those limits. You need to keep the work area free of trip hazards. In particular, use good cable management techniques. If a cable must be run across a walkway, secure it so that it isn't a trip hazard. A good method is to cover it with tape across the exposed length that might be a trip hazard. Unless you've been properly trained, do not open or work on cathode ray tube monitors, CRT monitors, or power supplies. Both of these have capacitors that will retain extremely high amounts of voltages and can be dangerous. Also, CRT monitors are not environmentally friendly. Follow your local regulations on their proper disposal. In case of an electrical fire, unplug the power source or turn off the circuit breaker. Use a Class C or multi-class extinguisher, and remember, never use water. If you use water, there is a risk that you will electrocute yourself. Now let's finish up with component safety. First up, protect components from electrostatic discharge, ESD. Now, ESD is caused when two electrically charged objects that have different amount of electrical charges come into contact or close proximity, creating a sudden flow of energy between the two objects as they normalize their electrical charges. ESD can damage sensitive components, particularly the CPU and/or random access memory. Using a specially designed ESD mat will help to reduce the chances of ESD. Better yet, using an ESD strap will also reduce the chances for ESD. The strap goes around the wrist and then is clipped to a ground source, usually an exposed metal surface inside of the case of the piece of electronic that you're working on. This will help to reduce the chances of a spark when working on equipment. You can also practice self-grounding. This is a normalization technique that's used to equalize the amount of electrical charge between the worker and the equipment being worked on. After the case has been opened and the ESD strap is attached to a ground source, touch an exposed metal surface inside of the case before actually touching any of the components. This will normalize the electrical charge between you and the equipment that you're working on. In some cases, actually attaching a ground strap from the piece of equipment to a ground source is advised. One way of helping to control the risk of ESD is to control humidity levels whenever possible. The possibility of ESD increases as humidity decreases. Humidity levels below 60% are when the danger becomes more prevalent. Now that concludes this session on the introduction to safety procedures. We talked about governmental regulations, then we talked about personal safety, and then we finished with component safety. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. I'm Farrell, and welcome to PACE IT's session on environmental impact and control. Today we're going to be talking about your impact on the environment, and then we will conclude with the environment's impact on equipment. And with that, let's go ahead and jump into this session. We're going to start with your impact on the environment. First up, you need to comply with governmental disposal regulations. Electronic equipment is not composed of environmentally friendly materials. Items like your cathode ray tube monitors, CRT monitors, and motherboards have some dangerous materials in them that can leach into the environment if they're not properly disposed of. Always follow federal, state, and local disposal guidelines. Also, always follow your corporate disposal guidelines. Sometimes they are more stringent than the governmental regulation. While talking about your impact on the environment, we also need to discuss material safety data sheets, MSDSs. These contain safety information on material found in the workplace. They will tell you what known health issues are associated with the material. They will inform you about the physical properties of the material, so what their flash point is, and the toxicity of the material that you're working with. MSDSs will also outline the proper disposal methods for the material, and they will also tell you about the steps that you need to take if exposure occurs. Now, each workplace will have its own set of MSDSs. It's up to you to know where they're kept, and you also need to know what the common hazards are. Now let's move on to the environment's impact on equipment. First up are power issues. And when we're talking about power issues, the first thing that we need to talk about are power surges. These are an upward spike in electrical current. They can severely damage sensitive components before circuit breakers can engage. Now, surges can be caused by anomalies in the power grid. They can be caused by lightning strikes, and surprisingly enough, they can be caused by power being returned after a blackout. Then there's the brownout. This is a sag downward in electrical current. These can also severely damage sensitive components as the components strain to draw current that is not present for them to draw on. The most common cause is overloaded circuits, either within the building or at the power grid level. Then there are blackouts, the sudden complete loss of all power. Now that we've outlined the issues, let's talk about the control. First up is the surge suppressor. It will protect against spikes in power only. Now, surge suppressors are better than nothing, but better yet are battery backups. The battery backup protects not only against spikes, but it also protects against brownouts and helps to mitigate the effects of a blackout. Battery backups work by taking wall current and delivering it to a battery or a set of batteries, which both store and condition the power before delivering it to its destination. Battery backouts will even out the supply of power. They're very beneficial to have, and they will prolong the life of your equipment and help to reduce power issues. Now let's talk about heat and humidity. Heat is an enemy of electrical components. High heat can cause the burnout of sensitive components. Humidity can also become an environmental factor. If humidity is too low, ESD becomes a danger. If humidity is too high, then moisture becomes an issue. So let's talk about how you can mitigate against heat and humidity issues. First up is airflow. Poor airflow allows heat to build up, so good ventilation is of primary importance. Ensure that there is adequate space around the equipment so that air can move between them. In dusty environments, use additional filters and enclosures to reduce dust buildup. You should also remove dust and debris from the inside of cases on a regular basis. Compressed air and specialty vacuums can be used to do this. You should always use proper component handling techniques to protect against ESD. Always wear an ESD strap when working on computer systems. You should also practice self-grounding. When you're transporting sensitive components, use an anti-static bag to protect against ESD. Now that concludes this session on environmental impact and control. We talked about your impact on the environment, and then we talked about the environment's impact on equipment. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on communication and professionalism. Today we're going to be talking about best practices for professionalism. Then we will move on to dealing with difficult situations, and we will conclude with confidential customer material. And with that, let's go ahead and begin this session. Let's start by talking about best practices for professionalism. First up is using the appropriate language. Avoid the use of jargon and acronyms whenever possible. Remember, the level of technical detail should be suited to the customer's level of knowledge. Take the time to explain terms when required to make sure that your customer knows what you're talking about. Always maintain a positive attitude. A positive attitude goes a long ways in any situation. You're the one who gets to choose your attitude. A positive attitude goes a long way toward making the customer feel better about a bad situation. Don't let the customer set your attitude. Listen carefully and don't interrupt. A good technique is to restate the problem or issue in your own words to ensure that there is a proper understanding between you and the customer. You need to be culturally sensitive. Your words and actions may offend others. Be aware that others may not have the same cultural background. Different cultures have different taboos in the workplace. The wise technician knows this and will adapt to the situation. Always be on time. Be respectful of your customers and don't be late. 8 o'clock doesn't mean 8:05. If being late is going to be unavoidable, call or notify the customer as soon as possible. Always avoid distractions. Focus on the customer's problem or issue. You are there to resolve the customer's issue or problem, not to do anything else. Silence your cell phone. Why irritate the customer by taking unnecessary phone calls? When dealing with customers, leave your cell phone in your pocket on silent mode. Your coworkers can be a source of distraction. Minimize the interruption by your coworkers by letting them know you are busy. Focus on the issue at hand. Personal interruptions should occur rarely when working with a customer. Your personal issues have nothing to do with resolving the customer's complaint or problem. Now let's move on to dealing with difficult situations. Avoid arguing or being defensive. No one wins an argument. There are only losers when an argument occurs. Being defensive closes down opportunities to improve, so strive never to be defensive. Don't minimize customer problems. The problems are of major importance to them, even if they are rather simple to you. Their issues are yours to resolve. Remember to avoid being judgmental. The customer doesn't have your knowledge. If they did have your knowledge and skills, you wouldn't be there. Also, no one likes to be judged, so always be respectful and courteous. Clarify the customer's statements. Ask open-ended questions, not yes or no questions, but questions where they have to think and give you a more in-depth response. Narrow the scope. Focus on the real problem rather than on the symptoms. And remember, always stay focused on resolving the problem that you're there to fix. One way to avoid difficult situations is to set and meet expectations. So first up, if applicable, offer a different repair and/or replacement option. Sometimes your customers can be concerned about the amount of cost of the repair, or they can be concerned about the amount of time. Sometimes you can create a trade-off to where it might cost more but take less time, or take more time but have it cost less. Always provide proper documentation. Document the repair process thoroughly. Also, always document the services that you provide thoroughly. You should also always practice good communication technique, so you need to properly communicate the process. The customer should always know at which point in the process the fix is at. There should be no surprises for the customer when you're done with the repair. Another good technique is to always follow up and to verify customer satisfaction. Whenever possible, check back with the customer at a later date to make sure that you solved their problem, or if you need to reschedule another session. Setting the customer's expectations and then meeting those expectations will solve many difficult situations before they ever have a chance to occur. Now let's talk about confidential customer material. First up, remember, the data is not yours. Return it to the owner when you find it. Unless you're directed to by the owner, you should never go through confidential customer material. When you do come across confidential material, don't talk about it. Discretion is key in these situations. Talking about confidential material can lead to termination or in some cases even prosecution. And finally, always give customers an opportunity to save their data. While a reboot will solve many problems, it can also create some as well. Now that concludes this session on communication and professionalism. We talked about some best practices for professionalism. Then we moved on to dealing with difficult situations, and we concluded with customer confidential material. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one. Hello, I'm Brian Farrell, and welcome to PACE IT session on dealing with prohibited content or activity. Today we're going to be talking about first response, documentation, and then chain of custody. We have a fair amount of ground to cover, so let's go ahead and jump right in. And first up is the first response to dealing with prohibited content or activity. Now, prohibited content or activity can be anything that is against the law or restricted by company policy, as in unauthorized programs being installed, additional hard drives being added, virus activity and other malware, unauthorized access and viewing prescribed content can all be deemed as either prohibited content or activity. As an IT professional, it is your responsibility to know your organization's IT acceptable use and security policies. So what are your responsibilities? First off, you need to know how to identify prohibited content or activity. Recognize that the activity or content is either unauthorized or illegal. You need to know your organization's acceptable use and security policies. If it is against policy, it is a security incident by definition. Report it through the proper channels. If it is clearly illegal, the obligation is to report not only through the chain of command, but also to the proper authorities. To not report an incident is to become an accessory to the incident. Follow the proper procedures for reporting, so you need to know your organization's security policies. You also need to practice data and service preservation. All data and services need to be preserved as evidence. Often the best approach is not to touch the system and to restrict access to it. Turning off the system or using the keyboard can destroy vital evidence. If required to stop a virus or malware attack, unplug the network cable only. Other than that, leave the system alone. Now let's move on to documentation. Proper documentation is vital. Use your organization's appropriate documentation form. So you need to know your organization's acceptable use and security policies. As a first responder, your observations can be key evidence, so you need to document your observations thoroughly. Interview and document the responses of other people involved. Documentation can be used as evidence. A chain of custody document is vital in any proceeding. Properly documenting an incident can lead to improved future responses. Some of the things that you need to document are any changes that have occurred since you first responded to the prohibited content or activity. Document any steps that have been taken to reduce security risks. Remember that any changes to the system may alter the evidence. Remember to preserve the situation as close to how it was found as possible. Now let's move on to a chain of custody. Chain of custody logs establish control of the evidence. Chain of custody logs show who has had access and when they have had access to the evidence. Chain of custody logs in themselves are also evidence, as they verify what is presented in court is the same as what was collected. An improper chain of custody log can negate any evidence that has been collected. You need to work at protecting the evidence. Restrict physical access to the systems involved. Never power down the system. The contents of random access memory can be recovered with specialized tools, but it is volatile, which means if you power down the system, it's gone. If anything is changed, evidence may be lost, so do not access files, as the attributes will be changed and evidence will be lost. Secure the evidence. Create a solid chain of custody. Now that concludes this session on dealing with prohibited content and activity. We talked about the first response to that prohibited content or activity, and then we talked about documentation. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing another one.